Good morning, everyone, and thank you for joining us today on our Livestream Summit, MMC with Thrust Behind Construction. This event in our series is focused on modern methods of construction and how it's thrust behind modernisation and efficiency within the industry. Today we have a mixture of presentations and interviews with a panel of industry experts who will also be joining us at the end of the event for a live Q&A session. If you would like to ask a panel a question, please use the Q&A function below. On our panel today we have Ken Davey, who's an associate at Supply Chain Sustainability School, Luke Horton, Sales Director at Sapphire, Tom Hall, Chief Economist for Barber, Daniel Leach, the Group CEO for TDS Design, Regan Cook, Marketing Manager at Sapphire Balconies, Laurie Pomeroy, Sales Manager at Duty Point, and Nick Horton, the Marketing Manager at Sapphire Balconies. I'd now like to introduce Ken Davey, who's the Associate at the Supply Chain Sustainability School.
Hello Ken, glad to have you on board today. Thanks for joining us. We're quite interested to hear your take on the Supply Chain School's take on, firstly, if you don't mind, just giving us a bit of why MMC, what is MMC? We hear it as a buzzword quite regularly in magazines and offsite and DFMA and all the rest of it. Tell us a bit of background behind what MMC really is in its truest form.
Hello Nick, thanks for the invite to take part today. MMC, Modern Methods of Construction. It's a fairly modern term insofar as it was first used in 1926, post-World War I in the UK certainly. But it applies to a wide range of different construction techniques, products, and various other methodologies. And it's not just about 3D volumetric, as some people might think from what they read and what they see on the media. So the school was set up several years ago initially to look at sustainability issues and developed an offsite capability 2015, and that offsite capability has expanded into developing educational material around MMC and DFMA, which is Design for Manufacturing Assembly, to help upskill the supply chain, including designers and other consultants working in the construction sector. A lot of what the material is actually useful to other industries as well. If you take a look at the school resources, which we will do later, is there are topics in there which are equally relevant for lots of other sectors. So setting the scene effectively, obviously this is me as Nick has introduced me. I am a registered architect. I've been in the profession for almost 40 years. My first involvement in offsite involved work for the Ministry of Defence, which included single living quarters. A few people will be familiar with the term. And interestingly, a police headquarters, which actually had a prefabricated armoury. I was the lead architect for a programme of house block modernisation for the Scottish Prison Service. Worked with the client to redefine the standards for cells and the ancillary accommodation working from the inside out. And then 6 new blocks were built using 2 different construction methods. Precast volumetric modular units was one of them, and the other was flat pack concrete 2D panels. From 2014 through to 2018, I was the head of offsite and MMC research for a tier 1 contractor, part of a small innovation cell looking to change the way that my employer actually built and completed developments. I currently run my own one-man architectural practice in North Yorkshire, and in the past year or so, I have been also working with the Supply Chain Sustainability School to develop the educational material, which I spoke about a few minutes ago. So that's me. Setting the scene is basically why MMC across the construction sector. This is where we're going today. I'm going to try and cover these 4 items in enough detail to give you a broad overview of where we are with MMC, and finishing off with some information on the school and how the school can actually help. The case for MMC is well and truly proven. There have been over 160 publications produced in the last few years. The bottom right is the Modern Methods of Construction Framework definition, produced in collaboration with the Construction Leadership Council and numerous house builders and other interested parties. And that is actually one of the things that I'm going to have a look at. As I said earlier, the term MMC is simply not new. The Chinese had developed a method of construction using timber frames, which actually locked together without the need for nails. And they spent 5 or 6 years assembling components before they then built the Forbidden City in Beijing in just 3 years in the 15th century. As I said earlier, in the UK, the term MMC was first coined in the 1920s. This started with the New Methods of House Construction Committee, which later became the MMC Committee. And there was a great push post-Second World War to adopt construction industrialization, which is another way of actually thinking about MMC, because of the destruction of almost 1 million homes and general housing shortage. Sounds a bit like deja vu, but there we are. So, a quick reminder, these are the government construction 2020 targets published in July 2013. Quite a challenge if you look at a 33% reduction in cost. However, that's a reduction in the overall cost of a development from design through construction through actual operation and use. and likewise in terms of the carbon. Program, I don't think you can obviously reduce the program or the duration of in use. I think what we're looking at there is a 50% reduction in the duration from inception through to ready for occupation or ready for use. And then from an exports point of view, the UK is recognised as being the leader when it comes to BIM and design technology and other construction techniques. So perhaps if we have wider acceptance of MMC and DFMA, we can all generate exports from that knowledge.
So
that takes me through to the next part.
So that's quite an interesting point, Aaron. I noticed one of the documents you had in there was the Modernise or Die report, which has been quite widely quoted about the productivity of construction not improving. What we're looking at there with the costs and the program reductions and so on, much of that is about collaboration, or that's what it says to me really in looking at that. One thing I'd be quite interested in you just giving us a little bit of a further background or looking at the framework, as you might want to refer to it as, is where is the product off-site manufactured, or if somebody says, oh, I want to embrace this MMC concepts and so on, to what extent can they embrace it? What is the scale? Because we're quite familiar with seeing the stuff you talk about there, which you see on magazines of the volumetric stuff. And we get at the other end of things, you get a product which is being sold as a off-site product, which may only be partially manufactured off-site. Tell us a bit more about that and differences between these different approaches to MMC.
There's a full range of MMC from basic components. Probably one of the very, very first components which was manufactured off-site was actually a brick, which obviously has been around for a long, long time. And then you're tracking through from products like that into door sets and obviously composite windows up through components. And obviously I'll run through some of those in the next session. And this section we're going to look at on the definition framework. Right up to 3D volumetric, but off-site manufacture effectively, or MMC, means manufactured somewhere away from the work face, away from the final assembly point, and construction then becomes assembly as opposed to building. What we have with the MMC definition framework is and again, this is the cover. If you'd like to get a copy in the UK, you can actually download this from www.gov.uk and search for modern methods of construction, free to download. But the Construction Leadership Council collaborated with others, including Mark Farmer, who produced the Modernise or Die report, in preparing this definition framework, which gives us some common language. The idea is that we have a common language that everyone can use within the 7 categories. The framework also includes a term called PMV, which is pre-manufactured value, which is a means of actually measuring how much manufacturing has taken place in any particular project, and it gives us an MMC spectrum. And one of the reasons for creating the categories in the spectrum was to have lenders and manufacturers and others speaking the same language when it comes to the commercial side of modern methods of construction. From the framework, what I'll do is we have building typology and we have material genres, and in my opinion, we're missing a trick. The framework is heavily focused on residential accommodation, as you can see from the typology on the left. So as far as the framework's concerned, it's houses, houses, and houses. In terms of the material genres, the thing being that all of these material genres can be used in every other building sector, within reason, provided that they're suitable for the particular project. And even then, the framework actually, in my view, misses out, because one of the most common forms of residential construction is in situ concrete frame with light gauge steel partitions within the frame. So as good as the definition framework is, I think to a certain extent they've missed the trick by going for housing only. And obviously with something new, I suppose it's easy to pick holes and sort of possibly highlight things that should have been included. But that's what we've got. So if we sort of look at what that then does is category 1 is effectively 3D volumetric. Categories 1, 2, 3, and 5 are defined as pre-manufacturing. Category 1 is 3D volumetric. What we're looking at here is on the left is George Street in Croydon, which will be the tallest modular residential building in the world. It's currently being fitted out inside. It's pretty close to completion, should be completed this year. What some people don't understand about modules, though, is that there are different ways of actually building them. We've got a hot rolled point loaded module, and then we could obviously then have a line loaded light gauge steel module. You can see in one of the images that the steel frame module can actually be fitted out with timber walls and timber partitions. So there's a complete mix of materials. And on the top right, what you're seeing is something is a concrete module, which isn't used to any great extent in the UK, but very, very common in Singapore, where they're actually type approved by the Building Control Authority before they can actually be built. So there's a wide range within category 1, but it's all primary structure. It's the frame of the building as such. The difference between the point loads and the lined loads is actually the size of the foundation. And line loaded modules are ideal in a situation where there are poorer ground conditions, whereas say a point loaded module tends to need pad foundations, as you would expect for a steel frame. And then even on the George Street development, the centre of the tower is actually a slip cast concrete core, and that core provides lateral stability against the wind loads, which you'll get at 40 stories up. So that's category 1. Category 2 is often described as a flat pack system, and these are examples of different flat pack types of construction. We've got a light gauge steel, which can either come as an open or a closed panel. An open panel means there is no boarding on either side, so it's a simple frame. A closed panel can actually sometimes be closed one side only, with a board to be finished, perhaps with services, once it's actually on site and assembled in location. Bottom left, we're looking at a timber frame closed panel. Top right is cross-laminated timber, which was gaining ground in popularity until the regulations were changed last year, prohibiting the use of timber in any facades above 18 metres. And in the bottom right image is actually a flat pack student residences block. And that can actually be assembled without the need for scaffolding, which can be quite an advantage, obviously, looking at reducing costs, speeding up the assembly process and reducing prelims. Yeah. And on the right is a little diagram of what a flat pack system actually looks like. So the categories 1 and 2 are primary structure. Category 3 is also primary structure, but it's not just about, it's about different elements coming together. They may well be bespoke for a particular project rather than being a system that can be reused. Top left are architectural columns that are actually cut by F.P. McCann, and then we've got glulam beams, which B&K Structures use for numerous buildings. I mean, bottom right is the interior of the B-Sky B office in Brentford, which is a combination of traditional steel frame, cross-laminated timber floor panels, glulam roof beams, and then cross-laminated timber roof cassettes with the roof membrane pre-applied on the ground. And there's a little image on the top right here, which when people ask me, is there anything that you can't actually pre-manufacture? Well, top right, what you're seeing is a tower section from the Sagrada Familia in Barcelona. Engineers Arab have been working with a construction team to develop what is a pre-stressed stone assembly to speed up the construction, to try and get the building finished by the 100th anniversary of the architect's death in 2026. So there's a wide range of things in category 3. Just moving on then is, and I've jumped to category 5 deliberately because this is one of the pre-manufacturing categories rather than going on to 4. So what you're seeing here is a variety of items that can actually be pre-manufactured somewhere away from the final assembly, the work face on site. Top left, these are utility cupboards which were manufactured for Battersea redevelopment, and they took 11 site activities off-site within one assembly on-site, which was to position the unit, plug it in, and off they went. There's a little lintel assembly which allows brickwork to be pointed on the bench because these can be turned upside down before they're clipped in place. Although in this case, that particular item has a combustible polymer, so again, that can't be used now above 18 meters. You're looking at the tunnel lining for Crossrail, which was actually a precast component assembled on site, a precast concrete bathroom pod, which is actually quite unusual because most of the bathroom pods these days are actually either steel or composite or fiberglass with a light gauge or a hot rolled steel chassis. And that's quite a common component used in residential developments. You may find that you want to adopt MMC for residential, but you can't actually use the type of modular. So if you're using a steel frame or a concrete frame, or if you can still use cross-laminated timber, there's nothing to stop you actually using bathroom pods and at least having part of the actual development as a pre-manufactured component. And it's not just big scale components. On the right, you've got obviously a massive services riser, but in the top center is a very complicated valve assembly, which was put together in the factory before being taken to site and actually plugged into place. So that's category 5. Category 4 is described as additive engineering, and I think you can probably see from the right-hand image that you're looking at a printer of sorts. Bottom is a stainless steel bridge which has been printed to be positioned over a canal in Amsterdam. And top left is the largest 3D printed building in the world, which is actually a administration building in Dubai. It's a honeycomb concrete wall construction. It's a case of, what next for 3D printing? Things are moving on all the time, the technology is developing, and more materials are becoming appropriate in terms of the 3D printing process. Category 5 is, category 6. Confusing myself because we've already done category 5. Category 6 tends to look at traditional products, but actually at a larger scale and in a different manner. So what we're looking at here is a story-height block, which is manufactured by H&H and has been used for bungalows in Denmark. So basically the whole story in one block. There is the large format block, which again I think they're manufactured by H&H. And then top left, that product is described by Knauf as a prefabricated floor screed, which is quite interesting because it does actually go down more quickly than a wet screed. It uses something like 70 to 80% less water. So you're thinking MMC, but you possibly have to think sustainability when you're looking at some of these products as well. So it's quite a complex process in terms of going from 3D module primary structures right down to the last one, which is actually 7. And 7 almost feels like a catch-all for all the IT systems, where we're starting to see the use of proximity sensors, which were initially introduced for plant and machinery proximity, and then dust monitors. But we're looking at HoloLens, we're looking at drones, we're obviously looking at technology here that can be used to look above a ceiling without having to take the ceiling down. And then, interestingly, top left, for the architects who are interested, that is actually the scaffolding around Hill House in Edinburgh. So Charles Rennie Mackintosh's Hill House is undergoing major renovation, and they built rather tidy cage around the whole building to obviously keep it out of the weather to allow the work to proceed. So that's our MMC categories, and which gives us the MMC spectrum, a wide range of techniques, which takes me to the end of this session. Thank you.
So thanks for that overview on that, and it's quite interesting to look at that scale of the 1-7, and if anyone hasn't seen that, it is available on the Resi Build website as well, and we'll be sending around a document with a link to this after this presentation, so all the attendees today will be able to access that. Now, in relation to that sort of scale of 1 to 7, from a balcony context, we used to, before we're aware of this, before this piece of research was actually launched, but we used to manufacture balustrades off-site and bring them to a concrete balcony and then drill the posts and assemble the frame and so on. And at that stage, we thought we were very much manufacturing off-site. We consider ourselves a modern method of construction because we weren't doing all the welding and so on site. We're manufacturing that off-site. We're probably somewhere in category 6 at that stage. We then developed our balcony system into actually installing on the outside of buildings. You bring the whole frame along and so on. But I think to us, there's quite a distinct change actually moving from 6 to 7, where you're actually manufacturing the whole thing off site. So and the reason that has changed quite considerably is that your thinking becomes quite different as well. I think in terms of the amount of the approach you're taking to making sure that when it arrives in a good condition, ready for just slotting into the building, rather than having that mentality of we'll send what we can, and then when it gets there, the guys will sort out what they need to sort out on site and fit the drainage and fit the last deck boards and all the rest of it. But for what I think this is something which perhaps confuses the industry generally as to whether they're embracing MMC or not. What could you say about that? What is the intentions to where the government and the industry should be going to get this productivity which has been spoken about?
I think it's a case of finding the right product for the right project, and you cannot expect every single project to be fully 100% pre-manufactured. I think the highest level of pre-manufacture at the moment are something the order of 80 to 85%. But that scale, obviously, as you can see from all the different products, will actually go right back. But interestingly, from a balcony's point of view, you're probably in category 5, which tends to be almost a catch-all for all the different subcategories. I think the more that can be done off-site, the more that can be manufactured, the less people required on site, which then makes the COVID-19 social distancing issue much more easy to manage. But there may be impetus as a result of what's actually happened to increase the amount of pre-manufacturing and reduce the site labour as much as possible. And then some major contractors, Langer-Oort, for example, set their own targets, and the Langer-Oort target for this approach is 70-60-30, which is 70% pre-manufactured, 60% reduction in site labour force, and 30% reduction in the duration. And they've actually achieved that in one of the examples which I showed but didn't actually speak about, which was actually 251 Southwark, which is a 41-storey concrete residential block built using what I describe as a kit of parts.
Ken, one of the things we get asked quite a lot as manufacturing, no doubt a lot of those who are involved in this MMC and off-site manufacturing get asked as well, is when the word modular is used, it's assumed to mean that you have to choose a sort of completely bespoke square, nothing out of the ordinary. Certainly not the case with our system, but tell us a bit more about how in practice is MMC a constraint on what an architect can do visually and so on? Or talk us through some of these case studies.
Architects, designers should view MMC as an aid as opposed to something which might inhibit creativity. And there are a few examples, obviously, just to run through as to how different products assemblies have actually been used. The first one is the Citizen M Hotel. This structure replaced an existing structure which was 6 stories high. The transfer slab was left in place. It's very, very close to the Tower of London, so obviously in a sensitive part of London. Volumetric modular units were used to build a 9-story structure, basically with 3 extra floors, delivering 50% additional revenue earning space. So that the essence of this particular project was as much about client value as it was actually about MMC. But MMC has that capability to offer client value in comparison with other construction techniques. The facade incorporates Portland stone and reflecting some of the finishes in the surrounding area. But you're very, very close to a UNESCO World Heritage Site.
Yeah.
But quite a successful building, having used. The bottom left-hand image is the interior, so you can actually see that the aesthetic is totally different between inside and outside the building. But in my view, using the modules has not inhibited the creativity of the architects. Another example in residential accommodation built using a modern method of construction was the Murray Grove residential block, which when it was built was the first tall urban housing project using cross-laminated timber in the UK. 9 stories, no longer possible again because of this change to the actual building regulations. However, there are projects and representations underway, and I think one of them's from some of the architects involved in the CLT projects, to have the government reconsider to understand the characteristics of the material. So this was 27 meters high with 29 homes. And again, by using CLT, the floor slabs are circa 300 mil thick. Very, very good for acoustics. Very good for cold bridging. You'd be able to actually fix a balcony onto these slabs without having to have any special fittings, and you wouldn't then have a cold bridging problem because you're fixing into timber.
That's exactly what
so
we're
quite
doing.
an interesting take.
Yeah, sorry, I was just going to say that's exactly what we're doing with Urban Splash and some of these other companies associating with us outside, but we naturally get pulled more that way because of the nature of our balconies being aluminium as well, so it's lighter weight for the put-out force and so on.
Yeah. Yes, so the Urban Splash have produced some really interesting developments up in the Manchester area, New Islington and Manchester, which I do have some examples of in my wider vocabulary, but I haven't included one here. What I have picked up on is small-scale Y-cube development in South London. This is actually manufactured by SIGS, Sheffield Insulation Group. Interestingly, the modules I think were about 3 or wider than the standard, because one of the things about using modular and volumetric in the UK is the constraints on the road system and even the motorway network, with a 4.8 metre height restriction on bridges on the motorways, which obviously can be significantly reduced off the main A road network. But this development was sponsored by the YMCA. And apparently the heating costs are something like 80% of comparable traditional construction flats. There are 36 one-bed studio flats in this particular development. Dry construction, no scaffolding and no water on site when the building was assembled. But even right down to the domestic scale of architecture, this is an example from a small design practice on the Isle of Skye in Scotland called the R House. They have developed a design which can actually be purchased from them as a kit house, and it's a combination of flat panel and roof cassettes. What you're looking at in this particular example is a bit of a refurbishment alongside an extension which has actually been built using modern methods of construction. Then you might think to yourself, why use MMC in such a remote area? Well, Weather for one thing. If you can finish the building more quickly, then obviously the weather in the northwest of Scotland can be extreme. And then there are similar labour and shortages, the skill shortages across the country. So it's not just confined to, say, the big cities. And then MMC and some of the products are not confined to residential development. So although we're looking at housing today, what I'd like to do is just look through a couple of case studies on other types of development, starting with a little factory which was built. Yep.
Yeah, go for it.
This is the Vitso furniture factory near Leamington Spa. It's a single volume, 135 metres long, 25 metres wide by 6 metres high. The building was assembled in 23 days, which again is one of the big advantages of modern method of construction. And that assembly process would have required far less labour than actually traditional construction. This particular building has a modular roof light and window system and has been designed such that it can be easily extended, so it's like a modular grid system as well. So mass engineering timber is not all about residential. It has use for it in lots of other developments. One area of the construction sector which is probably further ahead in terms of actually off-site manufacture, pre-manufacturing, is the building services sector. And what I'm illustrating here is a very interesting development in King's Cross in London, which was the construction of luxury apartments within the Victorian gas holder frames. The MEP contractor Shipper Engineering Services designed the modules for the horizontal distribution, this curved modules, which was quite tricky. Obviously using BIM, they were all pre-manufactured off-site in York. And the development also included 270 plug-and-play utility cupboards, similar to the ones that I showed earlier. The gas holder frames are actually cast iron. They were all refurbished. So it shows that pre-manufacturing, off-site manufacturing need not be about rectangular boxes, which I think is one of the points that you picked up on earlier, Nick. And then finally, from an off-site perspective, the new Queen's Ferry crossing on the River Forth was built using bridge deck modules that were fabricated on the dockside in Shanghai. 110 modules, each of them weighing 750 tons. And I often think, why was that the case? Did UK, did Europe not have the capability? It might well be the case. I should thank Transport Scotland for the images for this particular project. But the company who manufactured these units, it's called the Zenwa Port Machinery Company, and they usually manufacture these massive cranes that unload the container ships. And that particular company has supplied the steel for the refurbishment, I think, of one of the major bridges in the US. I was going to say the Golden Gate, but I don't think it's the Golden Gate, but it's one of the close by ones. So the MMC pre-manufacturing on a global scale.
That's quite an interesting summary there, and it really proves the point that it doesn't have to be limited to rectangles and boxes and lack of design. A comment which I remember came up at one of the events we ran early in 2020 was that a car manufacturer always looks for higher standards than the basic MOT, and the reason they can do that is because of volume manufacture. Now, one of the points there which was made was that the car industry, for instance, is a highly repetitive, continuing doing exactly the same things in exactly the same way. Now, the point was being made really to demonstrate why construction can't move to higher standards of construction and so on. What's your comments on that kind of theory of it? Obviously, bridges and so on aren't going to be, you're not going to replicate that fourth bridge around the world, are you? But what's your thoughts on that?
You won't replicate major one-off infrastructure projects, but if you take it down to the level of the utility cupboard as demonstrated with King's Cross and obviously the Battersea development, there are elements of a building that can be standardized and reused. And I think Barrett Homes have an interesting approach when it comes to utilities cupboards. They basically have three versions, and when designers are actually working on new layouts, they're basically told these are the parameters of that particular utilities cupboard. Don't redesign it, simply use that component. Now, you could apply exactly the same model to lots of different things. In fact, that's effective for what you've done more or less with the balconies. And pardon me for calling them, say, Mark 1, Mark 2, Mark 3. So that whole principle could apply from full-blown 3D modular right down to some of the smaller components. And when you start to standardize the components, it means that the architect doesn't have to think about certain parts of the building, and perhaps they can spend more time on the aesthetics and the public perception of a building, which the planners are interested in. So by using this standard product rather than standard design, you can open up a wide range of opportunities for pre-manufactured MMC products.
Yeah, so you're flagging a quite valid point there, and really it's about the principle of the way you're applying things and having that repeatable principle, but giving people the custom exact length they're wanting or custom angle of something. But you're creating a way that you can replicate that time and time again and simplify the process and so on, which is ultimately what manufacturing a factory does, is that you've got most factories, or certainly at least our factories and others we work closely with, are working to lean production methods, are looking at the ways of standardizing stuff and how to make things more slick in manufacture. But applying principles is really the process rather than actually having a limitation to the design. But that said, one of the things we've found quite helpful in demonstrating this, and people are welcome to try this out on our website, is our CABS configurator, computer-aided balcony specifier. The point of that really is that people can play around with a actual configurator on this, and we'll be talking more about this at our next event, the digital event, that people can actually get a bit of a feel for what the look and feel of something may be, and realise there's not actually limitations to their parameters there, and there's still plenty of flexibility, but being able to, as you say, work to that kind of that level 5, if you like, rather than just the basic kind of what was done previously or what was done 10 years ago, 20 years ago, if you like.
But even at level 1, at category 1, is there are products being developed such that the technology is being shared such that the module manufacturers can use the same assembly. McAvoy's are collaborating, I think, with Premier in developing a system whereby the junctions, the joints between the hot rolled frame are standardized such that other manufacturers can actually pick up and run with that. It's focused on the education sector for schools, and I think that if people are more relaxed about intellectual property right, you would see more collaboration and more joint development, and perhaps we'd actually see some what I would say would be technology agnostic solutions. So effectively, anybody could pick up a design and actually manufacture it, and at the end of the day, the product would be identical regardless of who manufactures it. And I think it's one of the issues that needs to be, that will come to a certain extent, but it relies on different delivery models compared to the sort of lowest price tenders, shall we say.
Yeah, so I think it's that kind of paradigm shift really, from thinking that kind of, I've got to get my designer to do something which everyone can price, but it becomes a completely non-standard item, and it's quite unusual, and is applying new principles rather than learning experiences, and then go through that kind of tender process, all different packages, and then bring them down to the lowest price. It's about really taking it back upstream and collaborative working together, so you can cut out all that waste in the design and the processes, and make it much more effective. And I know you mentioned Laing O'Rourke earlier. Laing O'Rourke are really good at doing this. Is working right back upstream, where they can actually cut out all the things which happen at a site level by making sure that there's effective input done early on.
Yep.
So tell us a bit, Ken, about where does the collaboration is obviously a big part of the supply chain school. And tell us where the supply chain school actually fits into this broad picture of things.
What you've actually seen, Nick, is actually two elements of a wider suite of courses that have been developed in collaboration with the Manufacturing Technology Centre, the Construction Innovation Centre in Scotland, and the National Colleges Framework. And the idea being that we recognise, in fact, the supply chain school is funded partly by the CITB, Construction Industry Training Board, and partly by partners. I think the school at the moment has about 94, 95 partners, although that may reduce given the current circumstances in the construction sector. But it was recognised that the supply chain needed some help. So tier one contractors and other partners got together to fund the school, which is actually a free online learning resource. So anybody who would like to use the resources, it's all free. All you have to do is register. There are two ways of registering. You can register as an individual, or you can actually register as a company, or you can then join as a partner. Now, partner organisations can actually have the learning material tailored to suit their own particular personnel. In other words, they can pick out from the media that we've got. So if you want to, anybody wants to have a look, they can actually then just go into www.supplychainschool.co, as you can see across the top. Well, the school is the Supply Chain Sustainability School. But this is the off-site element of it. I got involved when I was actually working with a tier one contractor who was one of the partners, and the leadership group of the school develops the policy. And one of the things that we picked up quite early was to try and bring the design community up to speed as to what off-site, what MMC is about. But it goes beyond that, because the suite of learning material covers cost consultants, project managers, pre-manufacturing, so off-site manufacturing, and site assembly, site logistics. And all of this material is free to use for anybody who wants to register. Huge number of resources, various different formats across the school website, as you can see from this slide. One of the recent topics to be picked up on is the fairness, inclusion, respect, which I think probably is more than topical given some of the events that have been happening around the world in the last couple of days. Prior to the lockdown, a lot of this, the events were organised, were supplier days, or they were organised on specific topics. I was workshops on off-site, looking at different building types, residential development. We're developing material and as a means of looking at a particular project and trying to identify what the best MMC approach was, which might not be modular. But if you want to go MMC, what else could you do? So how do you choose, and what do you know? So some of what we're trying to do here is to educate people to understand what's available within different construction sectors, not just residential, and also in the different systems available, as we've covered with the MMC framework, the definitions framework. So as I say, what you saw today was just probably the tip of the iceberg and some of what's actually available. And specifically, obviously, looking at the MMC aspects. This is a sort of summary of what the school is actually doing. You can see off-site at the top right, far more on sustainability, which is understandable given that the sustainability school has been up and running for far longer than some of the other elements of it. And only an introduction to BIM, although BIM's important when it comes to MMC and DFMA, only an introduction because we feel that there are others who are better placed to actually handle that aspect of interlinking to construction industrialization. So these are the topics. As I said, that the school has been collaborating with the CITB to develop a suite of educational material, as the banner on this slide actually states, off-site construction. And these are the partners say, manufacturing training centre. I can't remember exactly what the NOC group is. It's a national organisation of colleges or something along these lines. And all of the materials CPD accredited. So if you have a CPD requirement and you register and then start to use the course material and the learning material as part of your normal CPD process.
Excellent.
This is the actual structure of the course material. As I mentioned earlier, design, project management, procurement, QS consultancy, all available. And even there are elements of the material which are actually designed for trainers. So as a trainer, you could go onto that site and actually download some of the material and use it to educate either your workforce or offer your services to a few other people. And then when it comes to MMC, it's not just the school. There are other ways of actually sourcing information, and there are usually some very good things to be picked up at some of the major exhibitions. And that's the end of this one, Nick.
Excellent. Very much appreciate your time on that and giving us a bit of an insight into what you're doing about educating. It's quite important. I think that MMC is done properly because there's a lot of assumption on some of the issues with the prefabbed houses after World War II are kind of seen as a bit of a barrier to why people might not embrace the current method or the new methods coming out now in the marketplace. But certainly it's quite insightful seeing what you've presented there. One last question from me though, and no doubt probably all the audience are wanting to know this as well, but tell us a bit about the picture behind you.
This is a little building in Gothland, which is actually a station on the North York Railway. The station had a little shop in the waiting room, but it turned out it was in the wrong location on the wrong side of the tracks. And I picked up a voluntary commission to design a replacement for the shop. So we took photographs, we took measurements, and I designed a little shop kiosk replicating the style and the colours of the Victorian buildings around the station. And the building itself was then built by volunteers. It's a little timber frame shop unit.
Okay, very interesting. Yeah, well done. Good. Well, if any of the audience have got questions for Ken, please add them to Slido. I'll comment them now, and we'll come back to them in the panel discussion. Thanks very much for your time, Ken.
Thank you. Thanks for inviting me to explain things, Nick.
Thank you, Ken and Nick, for a very interesting interview there. If you'd like to ask Ken a question on the live Q&A session, please use the Q&A function below. I'd now like to introduce Luke Horton, Sales Director at Sapphire Balconies.
Hello, my name's Luke Horton, Managing Director of Sapphire Balconies. I've been asked to give a presentation about designing cost out of balconies. So I'm going to cover this brief presentation structure today. We're going to give you an overview for those of you that don't know Sapphire and how we approach balconies and MMC. We'll go into standardization, what it really means for balconies. We'll look at some of the key cost-saving areas. We'll see how we can reduce waste to also reduce money in that area. We'll look at how we can actually make standardization really easy for those of you wanting to take advantage of that. And we will also look at some of the hidden costs that sometimes get overlooked. So, an introduction to Sapphire. We've been established since 1992. That's 28 years in the game now. In that time, we've sold over 15,800 balconies. Nearly all those are glide on in the last 5 years. This year, we should be producing close to 5,000 balconies across multiple plants in the UK. We remain 100% focused on balconies. We're not a jack of all trades. We're a very focused specialist. We continue to lead in thought leadership, but also in setting the standards in balcony. And as such, we're part of the new BS 8579 committee, shaping some British standards that relate to balconies. We continue to hold a record for 34 balconies installed in just 6 hours, which is pretty amazing. Here is the concept. It's a glide-on balcony, so you can see cantilevered steel beams connected to a thermal anchor. These project from the building. The balcony is fully factory finished with soffits, balustrading, decking, all in place from the factory and checked to high quality standards. The installation team are safely in the door opening there, not under a live load. They're protected behind some specialist equipment called a door guard, and there is another piece of equipment that we provide, which is the yellow counterbalance lift you see there. This simply offsets the crane hook from the normal position of being central over the balcony and means that it's possible to install the balconies underneath ones that are already previously installed higher up the building. This gives massive benefits and savings to contractors and developers on these projects because they can follow the scaffolding strike down and look to off-hire their tower cranes very shortly afterwards, because the balconies will also be closely behind. We'll have a brief look now at a video of the production method, so you can see more about how this is done and can bear this in mind in the context of the rest of the presentation. I trust you found that video interesting. We'll now dig into standardization and what it is and how does it translate to cost savings for balconies. There's a number of areas where standardization can also relate in cost savings. So firstly, looking at reducing design labor costs. Every single bespoke balcony is another design and it ties up a lot of labor. So reducing the amount of variations will be a great help. Production efficiency is another area. If you can improve production efficiency by minimizing the amount of variations, it means less changeovers in production, equipment, men, and everything can be lined up, and the speed on these batch runs really achieves its peaks. There's less risk of quality issues too, because as you get into a process and it becomes repetitive and a learned process, there's a benefit there in terms of quality, and mistakes are less likely to occur. Material wastage. We look carefully at how we utilize material. and we can go further into that with CNC machinery and CAD designs and so forth. Lastly, but not least, is looking at ways to reduce transport and storage costs being minimized. And there's ways to do that with stacking balconies. So let's dig into some of these key areas where money can be saved. Firstly, balcony footprints. So the main cassette frame of the balcony is one area to look at. The ideal on a project would be that you try and limit this to a small number of different balcony sizes. You may need different sizes to accommodate the London Design Housing Guide, for example, and the requirement to achieve a certain square meterage for different size dwellings. Now, having one size throughout a project would be lovely from a design and manufacture point of view, but it does cause complications in logistics. So we would look to have at least 3 different footprints of balconies. So this is a small number, but it's there's enough of them to enable the efficient stacking, like you see in this picture here, to reduce the number of lorries going into site. This also can be utilised in the storage area, so taking up less space to store. Another area that would mean more design work and another variation, you may have your balcony sizes down to 3 types as we've recommended, but then you decide you want to add a bit of style to the building. So you decide to have, for example, perforated metal panels for some of your balustrades on a number of balconies on the scheme. And on the rest of them, you decide to have vertical bar railings, as you see here. Now, they're all doable, but that is another variation. There'll be holes in different places in the balconies to accommodate these different balcony designs. And it does mean many more hours in design, as well as different batches in production. Different shapes of balconies. Anything is possible. I'd like to make that clear that Sapphire can provide totally bespoke balconies. But as we're focusing today on standardization, one area would be to decide on a limited number of shapes for balconies. Ideally, the whole scheme is rectangular, but if you want to add a bit of flair, like these trapezium balconies you see pictured here, that's all doable. Just limit the number of different shapes and sizes you have. Drainage. This is another area where there can be some serious cost savings. Also bearing in mind the combustibility requirements these days, it's very costly to get non-combustible downpipes accommodated in the buildings. Sapphire do have a controlled free draining soffit arrangement, which allows water to be drained to the front edge, not requiring any downpipes. We'd be happy to work with you to get the approval of your relevant warranty providers on the scheme, but in most projects these days, this is a very acceptable solution and one that really reduces costs. Looking at balcony depths, a Sapphire balcony standard range of depth, this is from the bottom of the soffit to the top of the decking, we would typically aim to be around 340 millimeters. That would be an ideal size that allows enough tolerance up, down, left and right around the steel cantilevered beams which are inside the balcony. However, we can achieve as thin as 300 and we can achieve up to 400 comfortably within that standard range. So 300 to 400 mil is a depth that's very acceptable to Sapphire. If you start to look below 300 mil, we lose tolerance around the arms. So it can be done, but it does add extra complication and risk to the project and the balconies fitting smoothly. You can also go over 400 mil, but again, that requires extra bracketry and supports, and all the materials are increased in the balcony. Interfaces is another area where there's a lot of cost. The ideal situation for a balcony that's fully factory finished is that the facade is a nice straight line. The balcony can then be pulled smoothly onto it, and there's not any site work required to cut in around features on the facade. So having a look at this floor plan here, we can see there's some triangular shaped precast columns on this particular scheme. It does mean that the balcony member either needs to stop outside the furthest point here and another trade infill between those columns, or it's going to require some bracketry supported off the balcony and some additional work on site. So if you can minimize the features in the areas where the balconies meet the building, that is certainly more cost effective for your balcony package. Other interfaces that we come across sometimes are, for example, vents that come out of kitchens and bathrooms, and there's the aesthetic idea that we'll hide these within the balcony. Again, all possible, but it does mean that the soffits can't be factory finished or the decking, because there's a final bit of pipe work to be connected after the balcony is in place. So by having simple vents in other places that don't interface with balconies, this can mean the balcony section is more cost effective. Colour selection is another area. Whilst colour can be an interesting way to add variety to a scheme, again, we would recommend that you match the colour variations to other variations. So, for example, you might have a 5 square metre balcony and you decide to do those in a bronze colour. You may have a 6 square metre balcony and you decide to do those in a gold colour powder coating. Well, that's good, because you've kept the sizes and the footprint variations together. You're not actually introducing another type. But what you would be doing with colours is, if your 6 metre square balconies, you decided to have both gold 6 square metre and bronze 6 square metre balconies, that would be another type of balcony. It's another batch in production. It's more design and procurement work. So just bear that in mind when varying the colours. Captive sections of balconies, interesting one. For many years, we've avoided these kind of balconies because we've tended to focus on projects where the balconies are projecting and easy to install modular balconies onto. However, there are solutions now that fit modular balconies in these kind of situations, but it's never going to be as cheap as a standalone cantilever balcony. So what we have here is some columns, brick piers, for example, popping up, and I'll play you a short video showing how they can be accomplished in an MMC method. So the balcony is slid in here with a simple hinged section that fits in behind the column. Alternatively, you could have an aesthetic, non-structural clad column that fits in after the balcony is in place. Some balconies are structurally challenging. This could mean there's more cost in the balconies where there are more anchors required in the balconies. So if we have a look at these balconies on the screen, one of these balconies is a nice rectangular balcony. However, it does overhang the corner of the building. The closest we can position our arm and our bracket in the slab is where this red line is. You can see it's quite a distance from the edge of the balcony. We would have concerns that that would be deflecting unduly at the point where it overhangs the building. And whilst it's possible to engineer something, this will all add cost. So if you can keep your balcony within the main building facade, that is a good suggestion from a cost point of view. If we look at the other balcony here, this is a corner balcony. It's an L-shaped balcony. Again, due to deflection concerns, we would actually have an anchor with an arm connected to it at the 45-degree angle, projecting out on the corner. So what we have in this situation is we're going to have to make the balcony in 2 pieces. We'll have a mitre on the corner. You'll have section 1 of the balcony, section 2 of the balcony, just mating together on that corner with a final site finishing. Again, that's 2 lifts with the crane now. It's not great for sitting on the back of a lorry for transport, and it does just mean there's additional cost added in the bracketry there. So if you can avoid that kind of situation, you'll be reducing costs for your project too. Other areas where cost is added, for example, is large cantilevers. So this is the projection of the balcony from the slab edge to the tip of the balcony. Now we would recommend, so if you've roughly got a zone of 300 mil from the slab edge to the outside brick face or rain screen cladding, for example, from that point out, the facade out, we recommend up to a maximum of 1.8 metre projection. It's not to say that bigger balconies can't be done. It does just put more strain on the bracketry and the arms. So we need to make sure it's engineered carefully and correctly, that it can result in extra anchors to ensure rigidity. So moving on to our next section, reducing waste. How do we reduce waste? Now, I want to make clear that the biggest savings come in what we've already been over. So that is reducing the number of variations and types. But there are other ways to gain other marginal savings. So if we design balconies so that they work, for example, to the projection from the building is made to be in modules that suit decking boards, this avoids unnecessary cutting and throwing away of waste decking, which allows costs to be reduced. And other ways of doing it is actually dividing the balcony width-wise by the amount of soffit trays underneath. So the soffit tray modules are typically 400 mil. So if your balcony divides into multiples of 400, then you'll be avoiding any bespoke soffit tray designs. And also the rafters and the framework inside the balcony, as you saw in the manufacture video, are also at 400 mil. So you avoid bespoke modules there. So taking all this on board, how do you take advantage of standardization and making this really easy? Well, we've been working hard and investing a lot of money in a tool, which is a computer configurator for balcony design. I'll play a short video to introduce the CABS configurator. Hopefully you can see how CABS will really make balcony design very straightforward. We invest continually in that system, so it's getting better and better all the time, with options for pricing in the near future to come out of that, as well as balcony designs. So let's take a look now at hidden costs and where they can make a difference to the project. Firstly, we'll watch a balcony installation video so you can see how slick this is on site. So some of the key differences between the sapphire glide-on balcony method and other more traditional steel balconies are as follows. With the sapphire balcony, you've got a combination of two metals. You've got structural steel beams projecting out from the building. You have the lightweight aluminium cassette, which sits as a chassis on those structural steel arms. So you've got some benefits there. You've got the rigidity of the steel arms doing the heavy lifting. You've got the benefit of the lightweight aluminium to reduce the amount of brackets you need in the building and the overall weight on the building. Secondly, the anchors in our system are bespokely manufactured to suit the project and the balconies on that project. The reason for that is we know that rigidity of balconies comes down to a large degree to the rigidity of the anchors. So we tend to avoid using off-the-shelf balcony anchors because we know we can gain 2 to 3 times more rigidity and strength through a bespoke designed anchor. Lastly, there's some massive savings in the speed of installation. 34 in a day is a record, but we are consistently achieving around 20 in a day where the site's well organised and the craneage arrangements allow us to feed the installers with this kind of level of balconies. So this is a huge benefit for the customer in terms of the amount of craneage that can be saved if you can off-hire early, sometimes between £5,000 and £10,000 per week in savings. Let's have a look at the anchors. So here you can see on screen one of our anchors, and on the top right here you've got the image of what is normally cast into the concrete slab. Now the top bolts there take a lot of strain. Let's have a look at the bottom diagram. This is a simple structural engineering diagram. So as you can see, the balcony is hanging off the bracket in the concrete. There's a downward force there, which is causing a moment, a turning force. And that puts a lot of stretch and tension on the top bolts of that anchor. At the bottom, you have the opposite force happening. The balcony arm, the plate on that is trying to compress in towards the concrete slab. So any material used as a thermal break is under massive strain here from the load of the balcony and the extra weight put on by furniture and me and you walking out there as well. So this all contributes, as you can see at the tip of the balcony, to some deflection. Now, our aim in using this anchor is to really reduce the amounts of bounce and increase the rigidity of the balcony. So the differences between this anchor system and many others on the market is the size of the top bolts. They're 30 mil diameter to bars, so that's 2 to 3 times thicker and stronger than other systems out there on the market. The thermal brake is a hybrid system made up in the area where there is compression of a resin thermal brake, which is non-compressible, similar strength to a piece of steel, and the top part is an insulation product for extra thermal efficiency. Overall, it fully complies with the Part L thermal regulations. So, bearing in mind these key differences, when you're a surveyor or you're doing a comparison on the different routes that you could procure a balcony, how do you actually tangibly work out how they would relate to your project? Now, we've had this question many, many times, and we've created a tool which you're welcome to use to help you assess the balconies properly and ensure you make the right decision. So step one in this tool is that it's populated, and Sapphire would normally do this to help you, with the quantities from your architect's drawings. What we look at is there's a number of yellow cells throughout the tool, and these are for you to put your numbers in, so it gives you real life situation for your job. So one of the areas that we look at is the bracketry, for example. So we look at what's the cost of the thermal anchor that you would have to use if you were using an alternative system to Sapphire. What's the cost of the stub that would attach to that? And what about the concrete frame contractor? That's another trade that may not be in your balcony comparison, but there's a lot less anchors for the Sapphire balcony system. Now, if you went to your concrete frame contractor and said, I want to put an additional 200 anchors in this project, I can bet you that they would want an uplift in cost for the work associated. Well, let's reverse that. If you can take a lot of anchors out of the project, how much can you achieve in a saving in the concrete frame? So that's for you to put a number in there. Then there's other things. So every less bracket means less holes through your facade. So that's less waterproofing, less fireproofing, and there's a cost in those trades as well. So just being able to run straight across the facade is the easiest option without having to dress around additional bracketry. So you can look at when you combine those things, say the cost of the thermal anchor, the cost of the anchor, the stub fixed to the anchor, the cost of the frame contractors setting it out and positioning it, and the cost of the fireproofing and waterproofing. You can see in this worked example, you're actually adding up to about £475. So for every anchor you can eliminate on the job, you're saving £475. Now, moving on, if we actually have a look at the programming implications, so you may very well be used to traditional bolt-on steel balconies. So how many of those have you achieved on your last project in a day? Just put the number in there. And we've put conservative 15 balconies in for the glide-on. And we've worked the calculation on a 3-day week because the crane may not be available. There may be winding off during the week, so it takes account of that. There's also a section for defects and quality. So with some methods, it requires a lot of on-site finishing, and sometimes that attracts additional costs for snagging works or sorting out of tolerance casting, for example. You estimate what you think that may have been, perhaps going from experience in your last job, and put that in if it's relevant. We can then see from those yellow boxes you filled in, it gives us a report at the end. So on this particular project, from the choices the customer made here, this was actually saving them £159,000 on the project. It was improving the deflection by 5mm by using the sapphire anchors. It was also saving 10 weeks on program, which is a massive benefit if you can start other trades such as landscaping earlier and getting your cranes out of the way. So some real life case studies here. There was one developer that filled in these numbers for us. They had an aspiration to build 2,000 units per year by 2022. So if you multiply that one job out into the kind of quantities they're talking, that's £1.394 million of net profit they could have made by making the right choices on the balconies they use and taking advantage of these savings. So just to recap, this is how we got to the savings: £34,350 less thermal anchors, similar amount for the stub brackets not required, 22,900 on the concrete frame, 17,000 saved by fireproofing and waterproofing not being required to penetrations, and then a further £50,000 on craneage by finishing works early. So let's do the lineup. Here's the commercial lineup. I'm about to make my decision. I've got 3 prices. I've got a glide-on balcony supplier. I have a bolt-on balcony supplier. I have a second bolt-on balcony supplier. So on face value, the top 2 lines, 229 balconies, 945 anchors. You can see the totals there. So the glide-on balcony is coming in at 2.1 million. I've got a price for bolt-on at 2.2, but I've also got a price that's cheaper than all the others at about 2 million for bolt-on. So at face value, that looks very attractive. However, if you build in now the savings that we've worked through in this tool, what about the savings for those anchors, the concrete frame contractors, the cranes, etc.? If you really believe that you can take advantage of those savings, you can see now the bottom line is a very different picture. The price that was in the best position is still a good price, but is now second place. And there's a saving of £76,000 below this for a glide-on balcony with savings in other trades achieved. I trust this is useful. Please reach out to us on your next project that you have. We'll be very glad to help you achieve a job-specific lineup and help you work out the best option for your scheme. So to summarise this presentation, it's good to make your decision early so that you can achieve the benefit of working closely together to get your design as standardised as possible. You then need to commit once you've chosen the route that you're going for. because a PCSA can be an option if you're not in a position to place a full order, because that will allow a certain amount of design commitment to be made to help you work through and really come up with job-specific details, work with other trades if necessary to help you get the full benefit of these savings. We would recommend that your designer, your architect, or whoever's doing the design for the project embraces with the CABS tool earlier and uses options that are preset in there. Involve your balcony company early to assist, so we can help you with the structural frame design, for example, working with your engineers, making sure there's not too many brackets designed in. And lastly, consider the knock-on effects of your decision on other trades, which could be where some real meaty cost savings are. I trust this presentation has been useful. I'd like to thank you very much for your time. I trust you enjoy the rest of our event. Goodbye.
Thank you, Luke. If you'd like to ask Luke a question on the live Q&A session, please use the Q&A function below. I'd now like to introduce Tom Hall, the Chief Economist at Barbour.
Welcome, Tom. Glad to have you here with the Resi Build event, focused on modern methods of construction, having a look ahead of what the economy might have in store for us. I'm very keen to get into knowing a bit more about what your understanding is of the economy. But could you just start off by giving us a little bit of a background on who you are and what Barbour ABI does?
Yeah, thanks for inviting me to this. I'm Chief Economist of Barbour ABI and AMA Research. I've got a handy little summary slide here, actually. So Barbour ABI, very well known throughout the construction industry, historically more well known for construction project leads and understanding the planning environment. We also do client and competitor monitoring and market analysis. And then our sister company, AMA Research, is more of a construction and manufacturing consultancy, does a selection of market insight reports and also does bespoke work as well. Also proud of our partnerships with the government and the Office of National Statistics as well. So get involved in a wide range of things, really.
Tell us, what do you think the economy's got in store for us?
Well, I'm probably going to be a bit of a doom and gloom merchant today, but hopefully there's some green shoots which we can talk about as well. And I'll do my best to give a construction focus and also focus on the residential market as well. First slide I've got today is just really a kind of summary of the UK economy. So pre-crisis, we were locked into quite a low growth trajectory. Obviously, with the outbreak of the coronavirus and the lockdown, resulted in a very severe, unprecedentedly severe shock from mid-March. Over March and April, we lost 20 years of growth, 25% of GDP, and that's going to continue generally through May, and only now we're starting to see widespread recovery. So the graph on the left-hand side is our forecast of where GDP is likely to go, with some error margins around it. We generally think that the economy is not going to rebound as quickly as many forecasters, certainly originally, were suggesting, and really the economy is likely to only generally recover back to pre-crisis levels, kind of 2021, 2022, with a very severe overall reduction in 2020. On the right-hand side, I've got some summary statistics, which I'll just briefly talk about. So inflation at the moment is pulling both ways, I think. So while headline inflation is going down significantly, in 2020 it's likely to go below 1%. In the medium term, it's likely to pick up again. But lived inflation, so the products which people are actually buying, is running very much higher at the moment because the basket of goods doesn't reflect what people are buying at the moment. So some people are experiencing quite severe inflation at the moment, whereas overall among the goods and services which generally get purchased, it's obviously fairly depressed. Now, inflation is going to pick up over the medium term as the economy improves and as the oil price shock unwinds. Also, unemployment is going to increase significantly in 2020 and come down again slowly, and average earnings are going to take a fairly significant hit, albeit it will be much less severe thanks to the fairly early and fairly significant government intervention in March and April. That's going to recover over the course of 2021 and 2022, of course, assuming that that there's no secondary outbreaks, of course, which would lead to another lockdown and obviously another severe drop in GDP. So in terms of construction activity, after the Brexit uncertainty in over the course of 2019, we had fairly strong construction activity back end of 2019 and early 2020. Now, again, obviously, thanks to coronavirus, that's obviously taken a massive hit since then. Our research team have been validating projects individually. Through our research, we transitioned very early to working from home and what have you, so we've got a very good database now of what projects that are under construction in the planning pipeline that have been delayed or restarted. And the delays increased very, very quickly from mid-March and early April. They reached a peak of £70 billion value of projects that were delayed or off-site. That's about 50%, maybe a bit more than that, of all projects. Of those, the residential sector was by far the most impacted, 38 billion peak. That's due mainly to the decision of house builders just to walk off site throughout the UK. The medical sector has been, fairly understandably, the medical sector has been the least impacted, with a lot of essential work still continuing, and then a variety of different impacts throughout different sectors and throughout different regions, which I'll talk about in a minute. Since mid-April, however, we've seen increasing projects returning to site. I should probably explain the graph actually on the right-hand side as well while I do that. The dark blue line is the delayed projects by value over time, and the light blue line is the confirmed open projects over time, and the light blue dashed line is the confirmed restarted projects, which is a subset of the open projects. So you can see that confirmed open projects and restarted projects have increased fairly significantly since mid to late April. And so currently we've got £100 billion of confirmed open projects. Of this, about half, a bit less than half, are restarted, and we've still got a kind of long tail of delayed projects. So 30 billion at the moment, but we expect that to come down over the coming weeks as more sites reopen. The last residential house builders are returning to site over the next few weeks. Scotland's restarting, etc. So we expect that to come down fairly significantly over the next 2 weeks to a month or so. Next slide. In terms of drilling down a bit more into the project information, these two tables are just summaries by sector and by region of open, restarted and delayed projects. So in terms of and again, value again. So in terms of confirmed open, I should actually explain the colouring as well. So generally I've tried to colour, so if it's green, it means the sector is less badly affected compared to its size, and if it's red, it's more affected compared to its relative size. So in terms of confirmed open by sector, we generally, residential house builders have returned to site now. Obviously, the sector was the most affected, but comparing, we've got £40 billion worth of confirmed open residential sites now. The majority of residential sites have either been confirmed open or returned to site. As I said, medical healthcare, less impacted. We've got relatively few industrial projects that have been delayed, and therefore we've got relatively few industrial projects that have been confirmed open or restarted, which is interesting, I think. And finally, in terms of delayed projects, residential remains among the most even delayed, because we've still got all the Scottish sites to reopen. And other smaller residential sites across the country, but commercial and retail projects are now the most delayed, more delayed than retail compared to the size. So that happened fairly recently. So it does feel like there's some maybe reticent from the more commercially minded sectors to maybe return to site. But that's a bit of an emerging picture. By region, the open and restarted is very much dominated by London, due to the fact that London, obviously, with the magnitude and severity of the coronavirus outbreak in the early stages, saw widespread closures, and since then all those delayed projects have returned. In terms of the least confirmed open sites, got East Midlands and Yorkshire, and in terms of restarted, we had Wales and West Midlands. So that's just a fact that we haven't been able to confirm or confirm that there have been restarted projects in those regions, and they may be slightly behind in terms of where they are. In terms of the remaining delays, I've mentioned Scotland already, but obviously we're expecting to see the High Scotland number at 10.7 billion come down fairly significantly over the next coming weeks. The rest of the UK is broadly similar in terms of how much delayed projects there are remaining across the UK. And in terms of my final slide, I've just tried to summarise the key issues and risks really moving forward. So I've broken them up into short-term risks and then longer-term risks. So first off, a bit of good news, I think. We saw some very severe material and product shortages throughout April and May. Thankfully, these are easing after manufacturers and building merchants reopened. There's still some issues, but much less prevalent than before. The majority of issues were in your more base construction materials, so mortar, bricks and plasterboard, although it was fairly widespread, so there have been shortages of other materials as well. In terms of the planning environment, it's very much a mixed picture at the moment. Planning applications and updates have remained strangely strong, actually, throughout the crisis. Lower than averages before the crisis, but still maintaining momentum. It seems that the councils have been able to adopt remote working very successfully, which is really positive. So they have certainly kept working throughout the crisis, and planning applications have still been going in, which is great. However, towards the back end of the planning process is very much a different story. So contract awards have been incredibly weak in April and May. In January to March, they were very strong, averaging about £6.5 billion per month compared to an average bumps around, but about £4.5 billion a month. So very strong first quarter 2020. Since then, it's absolutely hit the floor. So £1.5 billion April and May, very low, which shows that people are very much sitting on their hands, maybe until the situation improves, which poses quite a lot of risk for the future. Certainly, we've got a lot of reports of construction companies who haven't won any projects so far this year, and if that continues, we're likely to see quite a lot of fears around viability and what have you over the coming months. Finally, you're probably aware of this, of course, but on-site productivity seems to be the biggest issue on site at the moment. Our research suggests a 20 to 30% fall in productivity on site. This is really going to cause trouble, I think, in the ability to finish projects to deadlines, and obviously that leads to disputes and that leads to financial pain. So we've seen some innovations, but also warnings that innovation and longer working hours are not going to be able to fill the gap. So really big challenge, certainly in the short run, as we return to site and get used to working with social distancing in place. And then finally, I've got some more medium-term points. So maybe slightly controversial, but the highest death rate that we have in the UK compared to the rest of the world gives us an idea of how the crisis has been managed by the government. And it feels like the problems are continuing by by lifting the lockdown without the infrastructure in place at the local level, which means a higher risk of subsequent outbreaks and possibly returns to tourist movement restrictions, which obviously would massively impact the economy and the construction industry. There are obviously wider economic risks, higher unemployment, already high debt levels even before the crisis for both households, consumers, and now government as well. And the unequal sharing of that runs the risk of an anemic response, recovery, or a more prolonged recession and stagnation, which is obviously going to massively impact both the economy and the construction industry. And then a more risk specific to construction, I've already mentioned the delays and the possibility of disputes. That's potentially likely to lead to more insolvencies, the risk of inflation as well, and the uncertainty weighing down the sector. We've also got to remember as well that the residential sector is now also heavily dependent on government subsidy through the Help to Buy scheme, which is planned to be phased out or at least tapered off. There's already warning signs and stories in the press about the need for more government intervention in the residential market, whether you believe it's the right thing or isn't. However, finally, there are lots of opportunities remaining. The budget at least remains on the table at the moment. Opportunities with the difficulty to improve innovation and solve some of the knotty issues, the productivity issues that the construction sector has been suffering from for many years, and the opportunity for a Green New Deal to really make a difference and a meaningful contribution to the future of the economy. So while this has been very much doom and gloom, there are some definite positives and opportunities there that can be grasped if we're brave enough. And I certainly hear widespread willingness to work in a different way, behave in a more collaborative way, and in partnerships more. And to me, that's the best way that we can try and come together and improve matters. So yeah, I think that's it, Nick. Thank you very much.
Thanks for that, quite insightful. And I've got a few questions, if you don't mind. Sure. Obviously, all the people watching this all the attendees can ask their questions on the webpage. You should be able to open the chat box and put their questions there, which we can answer live. We're obviously looking forward to having you in that panel. Just in terms of the short-term effects, to start off with, you obviously mentioned about the 30% of productivity. That's 30% less productivity rather than 30% of what it was.
Sure.
Now, with that, do you think that as we get on to, you mentioned obviously disputes on ones where you've got a particular time scale, I imagine there'll be lots of people looking at force majeure and all those kind of areas on that. But looking slightly further ahead than that, do you think that sites generally are going to be more the actual deadlines are going to be more stretched out as trades, particularly labour-heavy trades like bricklaying and so on, are actually working slow? Do you think we're likely to see a year programme with a few extra months on it instead of a year? Or what do you?
Yeah, that's a great question. So I think just to clarify, a 30% fall from where we were before. So we're operating at 70 to 80% capacity of where we were before is the research that we've suggested so far. At the moment, the information that we've collected suggests 3 to 6 months delayed on average, but obviously project by project it's likely to be very different depending on the circumstances and the characteristics. Construction is such a diverse industry that it is going to vary hugely depending on the circumstances. And it's also very early days. Everything's been moving so quickly. I think these are very much early estimates, but certainly from our research suggests 3 to 6 months. Generally, things are getting delayed, and anecdotal evidence suggests that there's a lot of discussions going on about extending contracts and all that kind of stuff, and widespread fears around penalty clauses and what have you. So, but yeah, watch this space, I think.
In relation to the on-site productivity, one of the things which no doubt most people should join this as an MMC event more generally are probably quite interested to know is, what do you think MMC is going to have a big role in actually solving that, where we're taking that productivity away from being site labour and actually putting it into factories and so on? Do you think that's going to be a good way forward in the future?
Again, good question. So I think there's opportunities to do things differently. I think the construction sector struggles with a productivity problem because of the high reliance on labour. And with labour going away, one of the blockers to improving productivity and adopting maybe some slightly more innovative construction practices is there. But however, it's absolutely not a panacea for doing that. So in terms of, if we talk about off-site construction very briefly, the manufacture techniques have been there, the scale should be there. Why hasn't it happened before now? Comes back to, for me at least, it comes back to investment and risk, and companies have not been willing to take the risk in that so far. So we talk about government intervention and what have you, but ultimately, someone needs to take the risk to be able to do that. So I think there's certainly more opportunity now than there has been for a period. However, I think we can't expect innovation, different ways of working to simply just fill the gap, because there needs to be other things that come into place as well.
So that obviously people haven't got familiarity, which is one of the big barriers at the moment. Is we've done it this way for many years, and so on. As you say, I guess probably the risk, and also the consequential project savings, and the risk, and it being a way of avoiding some of those risks on the disputes and stuff you were mentioning earlier. Might be something on that. But in relation to more the medium term things, there's a couple of things I wanted to ask you. One was around investment. Investment generally in the residential, particularly high-rise residential, is obviously based on a lot of overseas labour and so on, and also relies on confidence of buyers. Do you think that's they're both factors likely to be impacted, or what's your take on that, Tom?
Potentially, yes. So I think that the weakness in the contract awards shows that that the kind of large scale, big private sector projects have dried up in terms of coming through the pipeline. Certainly since the crisis has started, and I think that's a massive risk moving forward, especially if I think in the commercially sensitive sections of construction broadly, that's residential house building and the more commercial sided sectors, so retail, commercial, hotels and leisure and things like that. If the economy fails to pick back up again, if it fails to rebound, and we start seeing wider economic impacts, so the number of company insolvencies have picked up over the last few weeks starting to see increases in unemployment, etc. There's a real risk that as government support is withdrawn, and if the economy falters, then the pipeline could become very weak in the more commercially minded sectors.
Lastly, at the end of this year, we've got the B word likely to resurface, the Brexit word.
Sure.
Been fairly smothered by the C word recently, but what impact do you think, if labour's already being an issue, and we've got productivity, which is also labour related, do you think that's going to have much of a meaningful impact, or do you think that's mainly hype, or has been for the last couple of years?
Well, it depends on your view, probably, of whether Brexit is going to be a resounding success or a massive national failure. But I think the assumptions that most forecasters are working to at the moment is that Brexit, in whatever guise it has, is relatively undisruptive. now over the coming months, as you know, obviously we've seen, well, this week, but it would have been last week when this goes out, obviously the government confirming that it's not willing to extend the transition period. I think the resurgence of the kind of uncertainty that we saw over much of 2019 is likely to start to return, which is obviously another massive downside risk among all the other downside risks that we're dealing with at the moment as a result of COVID and what have you. And yeah, I think in terms of labour is obviously one of the likely to be big impacts through the coronavirus. I think my expectation is that the government will need to, through its new immigration controls, it will need to put construction workers as part of the key workers categories, because you know, there's such a big reliance on migrant workers, especially in London, which, as we know, is generally about a third of the overall, UK construction market. Wouldn't surprise me at all if we have some kind of semi-last minute announcement by the Home Secretary that construction workers are going to be put on that. But until that happens, obviously it's another massive risk for the industry to deal with.
Tom, thank you very much. We look forward to the questions which will come, no doubt, in the Q&A panel. Look forward to you joining us then. Thanks very much, Tom, and for all those in the audience, please do ask your questions on the chat in the webpage you're probably viewing this video. Thanks very much.
Thanks.
Thank you very much, Tom. That was very interesting. If you'd like to ask Tom a question on the live Q&A session, please use the Q&A function below. We will now be having a 10-minute break. When we return, we'll be hearing from Daniel Leach from TBS Design.
This is our 28th year in business. We've sold 15,800 balconies over the last 5 years. We're due to be producing 4,900 approximately this year across 4 factories. So this is one of 4 of our manufacturing facilities. We're 100% focused on balconies. So this is our one product, if you like, and we've just chosen one thing we can be best in the world at and put all our efforts into doing that very well.
It was really interesting seeing how all the different processes are operated, from folding metal to powder coating and cutting out patterns. It's just really interesting to see it come to life.
We saw how the components came together in a very, very sustainable way. We discovered there's no waste at all coming out of this factory, and which is very good to the environment as well.
It's so nice coming around. I'm a student of LSEC, and I never believe construction could go to this extent. I learned a lot by going around the factory and getting to know how some of these components are done before getting it to the site.
Very good and interesting visit around the factory, looking at the process of producing panels, bending them, forming them, and assembling them into finished balconies.
It was really interesting to see what you would do on the drawing board really come to reality, and you realise the kind of nuances that may inform your thinking in the future of how you might design.
Sapphire Balconies, we're part of a group called ATW. Our purpose, what's at the heart of our group of companies, is a statement: innovation to prosper the community. Yes, we do balconies, but we're also, our underlying purpose that backs up everything is our desire to do something greater than just build balconies. So we're a creative company, but using those skills to prosper the community around us.
Well, I think the idea of innovation as a means to prosper a community is quite good in the sense that every development in terms of a technology or a product is usually for the better good of everyone.
The fact that they carry people like us who are just part of a college along to developing and designing stuff like this, getting us involved in the design and producing a balcony that's going to be there for many years, shows that they're carrying the community along.
From an architectural point of view, it's quite nice to see a proactive approach at the manufacturer's end rather than just from the design end. So in the future, where more people work collaboratively, it's a quite nice approach to have that reliance on the products you're using. It's always innovate.
I was particularly impressed with the approach that the company appears to be taking to the work that they do, the innovation in their particular area of expertise, and more particularly that they seem to be willing to sort of share that with competitors for the benefit of everybody. Very impressive.
At Sapphire, we have many wow moments, moments when dreams actually happen. Here are 10 of our top wow moments since we started our glide-on balcony journey. Firstly, Staines Road. The reason this made us go wow was the fact it was our first ever glide-on project, and to see our dream of installing all of them in one day happened. What's more, despite the rain, we got 22 balconies installed in only 6 hours. The second project that made us go wow was First Central. This was a larger project, but in using the glide-on system, we managed to save several weeks' worth of crane time. Next, we had New Writtle Street in Chelmsford. Here we installed 36 balconies in 10 hours over a weekend. Then came our investment in double-stack trailers. This was another huge move forward for Sapphire, enabling us to reduce carbon emissions and increase efficiencies even further. To solve the industry's headache of bouncy balconies, the launch of our own anchor was another major step forward for us, and the foundation for us being able to guarantee our balconies' rigidity. To save several thousands in crane costs at Woodbury Down, we created a roof hoist to install an entire stack of 30 balconies without a crane. Following on from the tower, next at Woodbury, we installed 20 balconies in one day on a modular CLT building, again meaning that the programme and crane costs reduced from over a week to a single day. Panoma Wharf in Manchester. Here, we twice beat our single-day balcony install record, first installing 23 in a day, then installing 34 balconies in just 6 hours, making it one of our most wowing record-breaking moments. Then at Wembley, again we hit 30 installed in one day. And again, another performance worthy of a trophy was the extreme projecting balconies of 2.4 meters achieved just 1.25 millimeters deflection, whereas BSEN standards would allow approximately 14 millimeters of deflection. Explore more of our wow moments at www.sapphire.eu.com.
Well, first of all, I was quite impressed with the design and how easy the balconies got installed and how quick. Basically, it's probably one of the best designs that I've seen on the market, and the time that we use on site, it's quite low considering other projects that I've been, and we've done quite a fair few balcony jobs. I think this one worked very well was teamwork that we've done it together. Sapphire has their own management, our management, and working together as a team. I think it's very easy and very, how shall I say, very practical. Basically, you got the whole support what you need. If you've got any design issues, straight on, everyone knows. If you ask the question, they'll give you the right answer. So that's the most important thing for us. We've been backed up since day one on site. For any damages created by Sapphire has been, if we had it, there was next day we had it all replaced, and we never had an issue like that. Basically, becoming a Sapphire accredited, we had to carry on some specific training, how the balcony is being installed, what everyone needs to do in order to achieve the health and safety, especially working at heights, because this is a very high-risk job, which is being classed working at heights, and all the safe system that they've been put in place in order for no accidents to happen. Also, alongside with this, we've got a counterbalance lifting beams, which they really helped as well. We basically have to make sure all our guys get trained, everyone after getting familiarization training as well alongside with the training, and keep updating it whenever it needs it. Working at heights has been reduced dramatically, which is one of the most important thing. We got no surface to install. We got basically a glide on system that it comes easy. It's no risk of falling. We got edge protection in place, and I can't fault anything, especially design, especially the quality of the balconies. I can't see anything better than this. We usually tend to have a minimum 4 balconies a day, but we managed to do 12 in a day, 12 to 15, which is it says a lot.
Welcome back. I'd now like to introduce to you Daniel Leach, who's the Group CEO at TDS Design.
Hello, Daniel. Glad to have you with us this Resi Build event. Looking forward to your content on how BIM actually works in practice and how early collaboration is quite key in this whole field of adopting and working things with maximum efficiency. So over to you, Daniel. Tell us a bit about yourself and kind of where your interest lies in this topic, and then tell us a bit about the topic.
Sure thing. Thanks, Nick. Okay, so yeah, my name's Daniel Leach. Morning, everybody. I'm the CEO for the Technical Design Services Group. We have 3 businesses involved in construction, all focused around digital. Very passionate about adopting construction technology and digital workflows. I'm going to be talking a little bit this morning. I'll give a brief introduction about the group and where we're positioned. Talk a little bit about MMC and offsite, because we're quite heavily involved in that side of the sector. And then I'll talk about our involvement on Hong Kong International Airport over the last sort of 18 months, which is really centered around digital workflows and early adoption. So yeah, going to be talking about utilising modern methods of construction, which is a bit of a buzzword in the industry at the moment, and how we've worked in those areas and pockets of the market. As I mentioned before, there's 3 businesses within the group. Design for Structures, which is a structural engineering consultancy. TDS, who support manufacturing businesses with design and detailing services that are fully BIM compliant. And the Construction and Design Centre of Excellence, or CADCO as we're known, which teach and train young people in the digital skills that they need to forge a career in our sector. So starting out with TDS, we are a structural, what was originally deemed a structural steelwork detailing business, established in 1992. We've got offices in Telford, Central London and Greece. We kind of focus on 3 areas of the market, one being structural steelwork, the second being architectural metalwork, high-end feature staircases and balconies and things like that, and the third being light gauge modular building products. We do a lot of sort of panelized systems, modular volumetric developments and things like that. We're owner managed, so we're still very much a sort of family feel business. We've been BIM level 2 compliant since 2012. And our weapon of choice for delivering BIM is a system called Tekla Structures. In terms of what we are and what we do, we're really spread across the UK and do a very big and diverse mix of traditional construction projects, modular construction projects, structural engineering. We do some BIM type deliverables where we might be putting products or systems into a digital format for some of our manufacturing clients. The second of our three businesses is Design for Structures. Very much does what it says on the tin. We're effectively structural engineers. We set about setting this team up really because we found that the workflow between architects and engineers and the information that we were receiving to quote to at the front end of projects was largely incomplete. And what we were wanting to do was collaborate more with the structural engineer and the architect. That didn't go particularly well in terms of our fees are currently paid by the main contractor or steelwork fabricator. So architects and engineers didn't particularly jump into bed with us and get on board. So we felt ourselves, if we could create a consultant engineering team and bolt on what TDS did, that would be a really useful mechanism for bringing the digital skills further up the design supply chain. So Design for Structures at the moment do anything that you would expect a consulting engineer to do, from infrastructure design, substructure, superstructure, all the way through the REBA workflow. We obviously have a construction engineering team as well, doing things like calculations for end connection design or staircases and balconies and so on and so forth. The third business, which we're really passionate about, is CADCO. We set up the Construction and Design Centre of Excellence around about 10 years ago. Again, with a view to really creating a platform to train young people in digital skills. We now partner with Dudley College of Technology in the Midlands. They're an Ofsted outstanding training provider. The main reason for doing this was we felt as a business that training young people and bringing young people through the business was going to be absolutely pivotal to our growth. The problem that we got was we found that existing qualifications in the market were too generic. So we would end up sending our guys on sort of mechanical engineering type qualifications where they learned very little about what we did as a business, but obviously got a piece of paper at the end of the 2 years to say that they got a qualification. So we've created now a platform, a 16-week intensive platform where the guys are actually trained and taught by someone that does the job. So our Director of Teaching and Learning, Lee Drummond, has actually moved from our core business into the training business. We give them 16 weeks worth of intensive work-ready training. And with Lee doing the job day to day, he's obviously always kept up to date with the latest changes in construction technology, and we're able to update the curriculum and develop the curriculum regularly to ensure that the guys are getting the skills that the industry needs. I think for us, we're trying to use the digital technology that exists within construction now as a real enabler to actually attract talent into the industry, because I think one of the challenges that we've got as a whole country is making the construction industry attractive to young people. At the moment, when you talk about a hard hat, high vis vest, and not necessarily thinking about augmented reality, virtual reality, and some of the really exciting technology and developments that we've got in the construction industry. So we've got a number of legacy projects that we've worked on. I'm going to focus more on the TDS and D4S side. So you'll see on the screen there that we've worked on some of the biggest projects certainly in the London skyline. In terms of UK projects, I'm going to focus on three areas really, and they all centre around offsite and MMC. So this was a project that we delivered 3 or 4 years ago now for our customer Elements Europe. And it's a 450 bed student accommodation for Bath University, and all of this was made fundamentally offsite in a factory environment, fully fitted out and delivered to site on the back of a lorry, craned in and assembled. So our scope of services was largely around the structural frames and howick connections. and we provided all of the general arrangement drawings, fabrication details, and NC data files to allow the manufacturer to frame and all of the structure, as I say, in a very safe and secure factory environment. So anything that could be bolted to the floor, including furniture, kitchen, bathroom, were all fully installed in the modules prior to transport to site. And the actual start to finish on site was around about 22 weeks. So phenomenally quick compared to traditional construction.
Is it still frame? It's still frame approach, is it?
Effectively behind. So one of the interesting things about this project, Nick, is the facade that you can see there. It looks like a traditional building, but actually behind that, you'll see there, that's a snapshot of our model. So it's a series of rectangular steel frames basically behind that very architectural looking facade. So very simple, but very effective way of manufacturing and doing so in high volume. So obviously what we try and do on these modular volumetric projects is standardize the module types to allow for an efficient manufacture and installation exercise from our customer. But effectively, I think that the real leap forward with regards to modular and MMC is that, you know, a lot more can be done than just basic square buildings. I think that's one of the biggest advancements really on this side.
So a very relevant point and in that regard, because that's a topic which continually comes up with the word module seems to trigger a thought that everything will be very much in a box and so on, like a Lego block, if you like. But the fact is that the flexibility you're seeing on a project like that is quite wide and varied, isn't it?
Very much so. I mean, I think one of the things that the challenges that the modular side has got is really the stigma that still exists around the old prefab sort of cheap and cheerful type reputation. And I think it's really clear that you know, there are ways that you can standardize the design of projects and industrialize the design of projects to create economies of scale and mass efficiency, but ultimately you can still have a really architecturally inspiring look about a building. So, and I think this is something that, you know, we're really keen to push here. We get a lot of clients that approach us as sort of experts, would you say, in the field. The reality is we've been working in this area of the market for about 5 years, and you know, if we are going to truly push innovation and collaboration, then we have to make an environment where ultimately people can work together. We're going to find problems and we need to overcome them as a design team, rather than, you know, we've got a problem, let's apportion blame. I think that's a big thing for me. The next project is a similar system, same client, but obviously a residential project rather than a student accommodation. So again, just demonstrating that you can have different market sectors and different solutions. This one was for Pocket Living in central London. It's a 21-story modular apartment block. And again, for us, very much centered around a LOD 400 model that was fully connected, geometry checked, and we produced all of the GAs, fabrication drawings, and NC data files to allow the client to manufacture this one, again, in high volume. You'll see from this slide that the actual model that we produced on the right-hand side, there was a lot of repetition in this one in terms of ground floor up to about, I think, 16th floor, I think, was pretty much identical in terms of module types. So we saw a lot of efficiency and we were able to get a lot of the product and material out to the client very, very quick on this project, which enabled them to get stuck into manufacturing installation really quickly. The other area that we've seen a massive amount of growth in on the residential side is actually residential housing. So this particular project was done for another modular client. We're under an NDA on this one, even though it's 3 years old. So I can't divulge who the actual client was. But while the actual house itself doesn't look particularly exciting, the way that this particular project was delivered was very, very innovative from a BIM and digital perspective. So in terms of what our client was looking to do, it was basically take their light steel frame experience on medium and high-rise projects and come up with a solution for the traditional 2- and 3-story residential house market. And where I say this one was really sort of collaborative, the client themselves were very, very digitally enabled. So they'd already got a common data environment established. We used a system called Viewpoint for Projects, which enabled everybody to basically upload and download information into one local environment. They'd already got a BIM execution plan, and the project was run fully in accordance with PAS 1192 at the time. There was full coordination between design disciplines. So we had a weekly data drop, I think it was a Wednesday, where everybody uploaded and downloaded the IFCs from all of the relevant disciplines, so that we could use Celebri to run a full clash check, monitor progress on all fronts, and really ensure that this was fully designed out, so there was going to be no nasty surprises on site. Yeah, so we used an IFC file format for a full sort of open BIM philosophy. So we were able, what tends to happen on, we're finding at the moment on traditional construction projects is we'll get an IFC file from an architect or an engineer, but largely we'll be told we can't use it. So it's for information only, which kind of defeats the object really. So we tend to find all we can really use is the grid lines and levels on the model. Use it for geometry check-in, clash detection, and really just ironing out any potential issues and site problems that might have existed if we didn't do that. And in terms of the software that was used, it was a real sort of a real good example of the fact we use Tekla structures and Tekla TEDs for the analysis and modelling side, but Revit architecture and Revit MEP was used by the engineers and architects, as well as obviously the common data environment and Celebri for the clash detection. So clearly, software platform to enable that collaboration, and the IFC files really, while they're not 100% the finished article and completely polished, they're a really good collaborative way of sharing information in different software platforms. So the client ultimately was really pleased with the outcome, and they took this product to market around about 18 months ago, and there's a good probably 150 of these types of homes on a site at the moment over in Ireland. So so this has been tried, tested, and been introduced to the market. So we were really proud to be associated with a product of this type. So in terms of the overarching theme for today's event, really, I want to talk a little bit about the current UK procurement model, because I feel it's one of the real things that's stifling collaboration and innovation. So for us at the moment, typically the client and main contractor on this slide is probably a little bit false, but this is the way that we interpret the UK procurement model. I mean, ultimately, the client normally appoints the architect and engineer, and then the main contractor. So you could argue that the model's slightly wrong, but it's certainly how we interpret it. So I think one of the challenges that we get at the moment is that we get brought onto projects too late in the day. So ultimately, the client appoints the architect and engineer. They can only go so far with their model and their information, because they don't know necessarily who all of the relevant supply chain partners are going to be and who the relevant contractors are going to be. And what that means is that when we come onto the project late in the day, there's a lot of design development and coordination that we need to do with the architect and engineer just to actually get started on modelling our steelwork or our light steel frame or our balcony or our stair. And that really slows things down. So what we wanted to do as TDS is, currently we sit underneath the steel fabricator, and they pay our fees, they appoint us to do the project, and ultimately they sell the risk to us, and that's a real problem, because if there's something wrong, if there's a steel member that's incorrect or something clashes on site, it's us that picks up the bill. And that's what really is kind of stifling the collaboration and innovation that the main contractor and clients want. So we wanted to lift TDS further up the design supply chain, almost leapfrog the manufacturing clients that we've serviced for the last 20 years. And we wanted to work directing for the architect, the engineer, the main contractor, and even potentially the client. And that's been very, very slow going. As I mentioned before, at the moment, our fees get inbuilt into the manufacturer's fee proposal. And as such, we've found it quite difficult to explain to clients, architects, engineers, where the value really sits in getting our expertise on the project a lot earlier. So in terms of the current challenges that presents, the UK construction industry is massively risk averse. And the problem with that is that in selling the risk then, supply chain, we're creating an even riskier environment. That also then creates a culture of blame. And what we're doing is, rather than looking at what the problem is and trying to solve it, we're apportioning the blame to someone and passing the bill to them. And that's causing widespread business failures, contractual conflicts, etc., etc. We've got national skill shortages, as we know. We haven't got enough people coming into the industry. Just to stand still, we need to get 600,000 people into the industry just to replace the people that are going to be retiring over the next 3 to 5 years. So on top of that, when you consider and factor in growth into the equation, we've got a real challenge in terms of bringing young people into the industry. There's been a massively slow uptake in construction technology. Obviously, the government mandated BIM in 2011 and said that 2016, all government-funded construction projects, that BIM would be mandatory. The reality is that there hasn't been enough central government-procured construction projects to mean that this has been widespread adopted across the industry. In simple terms, it hasn't, and we still aren't being asked for BIM. You know, it's something that we've decided to do, and it's a route that we've gone down, but ultimately we're not being asked for it in terms of getting on UK-based projects. There's really poor change control discipline, so the scope on a lot of the projects that we work on is variable. The design develops and changes, but EWOs, extra work orders and variations aren't very well received, and it's usually a battle trying to get paid for the design changes and development that we've done. And what that creates is low productivity and low predictability. You know, a lot of clients want they want predictability around cost and time frame for delivery. And unfortunately, with all of the ways that these projects are working in the UK market at the moment, there just isn't that predictability because of all of the variable scope changes that happen on every UK-based project that we work on. So I wanted to talk a little bit to sort of focus on a project that we've been working on for about 18 months with the Hong Kong International Airport Authority.
Daniel, if I can just ask on that, the last slide you were looking at there,
yep.
What you're really talking about is, rather than this being a kind of a very much hierarchy-based kind of pass of risk, and the risk is split and moved all the way down the supply chain, what you're saying is basically, rather than having that culture where you're kind of very much a contractual relationship, by collaborating together, you're cutting out all the problems in the first place. You don't even need to worry about the apportioning of blame, and that is that how you're
absolutely. I think that the problem that we've got is creating this digital workflow, and the collaborative working environment is minimizing the risks on projects, because ultimately you're ending up with a more accurate model and less scope for things to go wrong. The problem that we've got with the way that jobs are procured in the UK market is that in order for the architect and engineer to design out and model the balconies or the staircases or the steelwork or the light steel frame, they need to know who is the balcony manufacturer, who is the feature staircase manufacturer, which light steel framing system are we using. And the problem is that at the point where they do their part of the project, those companies aren't appointed. And those companies aren't appointed until they've gone out to, the main contractor's gone out to market and priced out their balconies or their staircases or their light steel frame. And what that creates is the main contractor then goes, right, what we want you guys to do is design and detail said balcony or said light steel frame or said structure. But ultimately, if it's correct, you'll get paid. If it's incorrect, you won't. And so they're almost washing their hands of the fact that this could go wrong, because ultimately they've got the fallback of, well, if it's wrong, we won't pay for it. And I think that's the mentality that's got to change. We've got to find a way for companies to procure the services of specialist contractors, because ultimately the industry has become more and more diverse. It's more multidisciplined than it's ever been. There's more products and more systems on the market than there's ever been. what we've got to be able to do is get those little niche areas and those specialisms, get the structural guys, get the light steel framing guys, get the balcony guys involved in the scheme far earlier, be involved in the actual design and process, but in a way that's going to create more value. You know, value engineering is a term that we've heard for 2 decades. Value engineering to me means make it cheaper. And making something cheaper isn't creating value for the client, you know, because cheaper isn't always better. I think value engineering needs to be about finding the best solution, about finding the most innovative and collaborative solution so that the client gets ultimately a better project. Now, sometimes that might be cheaper, but sometimes it might not be. It might actually be spending a little bit more, but ending up with a building that performs better over a longer period of time, and therefore is a far more cost-effective investment for the client.
So really, one of the contractor comments in response to this, people might be thinking, well, if I'm changing the supply chain thing, I'm not going to get my competitive tenders, and I might not save that few £100 or the few thousand, which I could if I've gone out for prices 10 people further down the line and kept all my options open. What we're really talking about here is not about locking in a marketplace. It's about getting truly smart companies, if you like, working together so that you're creating that innovation, and together you're coming up with synergy, which basically cuts out all that risk and all the problems further down the line. And that's a much more smart way of doing the cost saving up front, rather than getting to the point where you've got an architect has drawn something quite complex, and you probably see it as much as we do, that sometimes a balcony design has got some very intricate details which are going to be quite expensive, but the contractor wants to still just get everyone to price that detail so that, you know, you can compare apples to apples. Whereas actually that complex detail could have been designed out and simplified early doors without changing the aesthetics, but further down the line, producing much bigger savings without all the hassle of actually getting everyone to try and price all these different options and so on.
I think there's 2 points really to what you've just said, and I think the first one is, you know, you just mentioned comparing apples to apples. I think one of the problems that we have at the moment is because the information that everybody is quoting to is understandably incomplete, because the architect and engineer can only go so far. What that creates is you don't have, when they go out for competitive tenders, I've always argued you don't have an expensive price and a cheap price. You have 2 different prices, because ultimately what happened is you've got 2 different people in 2 different organizations, both making a set of assumptions and guessing actually what the client wants. And what that invariably then creates is that the company that gets their price the most wrong wins the work. And then we then have the battle of how do we actually design and detail these balconies for a price that's now wrong, because we weren't clear on what the client actually wanted. Now, for me, you know, the ultimate irony in that is that if we find a way of creating better information for manufacturing businesses, we will then be able to look at ways that we can actually get costs down. So balconies are a really, really great example, because we get pulled onto so many balcony schemes, and you'll look at a project, there might be 250 balconies on the side of a building, and ordinarily they'll say, oh, there's 8 types, so you price for 8 types of balcony. And from a design and detailing perspective, let's say plucking figures out of the air, you were charging £2,000 for a balcony type. If you end up, instead of 8 balcony types and a design fee of 16,000, you end up with 35 balcony types because of all of the inadequacies and inefficiencies on the building in terms of the way the building's been designed. All of a sudden, your design fee and time goes from 16,000 to closer to 70,000.
That's just for the design of it.
That's just for the design, and you end up in this massive dispute in terms of why is it taking so long, why is it costing so much, and I think, you know, when you look at a balcony, 9 times out of 10 you might be tying into an existing halfing channel or a prefix first fix bracket, and what you've got is a bracket where you might have the concrete frame guys don't want to share their information, the company that's done the first fix brackets or the precast halfing channels are different to the company that's doing the balconies, and they don't want to share their information. So what then happens is you end up in a situation where instead of standardizing the balcony design, you end up with lots of one-offs, and that costs time and costs money. And the reality is, if you could collaborate with the concrete frame contractor, and you could collaborate with the company that's doing the precast half and channels, you could design the whole building. You could make sure that, how many times are we going to install a balcony, and when they're drilling on site, they hit rebar, they have to move something, and then all of a sudden you've got a bespoke balcony type. And I think, all of these things can be really quickly and really easily compromised and sorted out. But the reality is, because of the way that we procure the job, the concrete frame guys go, I'm not sharing my information. Balcony's not my problem. The first fix bracket guys go, our brackets are installed. We're not sharing our information. It's down to you to go and survey it. And then the balcony guys are sucking them up at the end, going, okay, all of a sudden we've got 250 balconies still, all the same amount of material, all the same volume of paint and everything else. But actually we've got 35, 40 different variations of the same balcony. And that's where, so much time and money can be lost. And that's where your contractual conflict starts. So if we can find a way of opening that up and collaborating, we can end up with a better product for the client. We can make sure that we're missing the rebar. We can make sure that we've got jigs so that the balconies can be installed in exactly the right place. So I think that those are the real. It's very obvious, and it's a very simple problem, but it just seems impossible to overcome.
So one of the points to pick up there, really, from what you're talking about, is you've got this whole risk thing going through the industry. Any company which is experienced in the industry, and that's like majority of companies working in construction, are going to have to price in a chunk for risk, because there's a known culture of that you won't be paid for certain parts of what's done, and that doesn't necessarily mean that you got it wrong or anyone was involved in that particular part. But there is obviously a lot of waste because of those issues which occur on sites. The fact is, if you get into a collaboration side of things, and the whole industry is moving towards a much more lean model, that risk amount which is being put in and priced in to everyone ultimately is coming out of it as well. So you're cutting out all of those costs all the way down the chain, aren't you?
I think over the last sort of 20 years, and I don't mean this with any disrespect to manufacturing companies and fabricators, the drawings have always been treated like a necessary evil. And as such, there's never enough time and there's never enough money to do the job properly and to really take the time. We call it in our business, we call it the hamster wheel. All of my guys are running on a hamster wheel, and the quicker they run, the quicker it spins. They never get any further along, because each project is the same. You're starting with an incomplete set of information on a price that you've had to guess, on a program that you've had to literally just jump into almost 2 feet and go, okay, we're going to sign up to a program that we don't know if we can meet, because that's the way that the industry is. That's what we've got to change. We've got to change the culture. And if you said to probably 95% of manufacturing businesses, okay, would you like to work on a model where you've got to sort out the design, sort out the detailing, create all of your drawing packages, and also take the risk for the fact that all that's going to be correct, as well as manufacture, as well as install, and as well as get your price right? Or would you like to work in an environment where all of the drawings and technical information and engineering is taken care of for you? You're quoting to a complete and finite set of information, so you know every nut, bolt, and washer that's on the project, and ultimately you can get stuck straight into manufacturing. You can be on site in 2 weeks' time installing. So I know which option most of my customers would take, and that would be the second one. So, but how do we create that? This is what I'm saying about this risk culture. In selling the risk down the supply chain, we're creating a completely inefficient model and a completely inefficient way of working. And what that's doing is creating contractual conflict. It's creating massive commercial conflict, because more money and more time is required, and then we all end up pointing the finger of blame at each everybody else that sat around the table, rather than actually going, right, let's throw some money at this at the front end. Let's create the digital asset first. Let's design this all out in a way that's efficient for everybody, and then let's move forward in a really open book way. I think you guys, I'm sure, are the same as us in that we're not looking to quote a project at 1,000 hours and deliver it for 800 and rub our hands together. We're more than happy that if the project takes 800 hours, that we bill 800 hours. And I think you guys would be the same. The cost of the material is the cost of the material. Your overhead is your overhead. Your cost of installation is your cost of installation. And as long as you can be open book and you can be transparent about that, we shouldn't all be throwing our hats into the ring, quoting different projects and guessing different things, because you're just not getting the opportunity to actually do the project to the way that the client might want it.
So we've talked here about the problems of the current supply chain. Really, it should be seen as a bit of a paradigm shift, I appreciate, but it should be seen as the opportunities which come from the MMC and the whole collaboration and the benefits and the savings this drives in, because it's easy to ask further down the chain, if we offsite manufacture this as a sort of MMC product, will it save me money? Yes, no, tick box. But what we're talking here is a bigger shift in the thinking, which is really a massive facilitator for the whole benefits of MMC to be unlocked, and that those savings to come about. Tell us about how that works in practice. Your example project you've got here.
Yeah, so we've been working on Hong Kong for around about 18 months now. Terminal 2, there's 2 roof structures effectively that they wanted to pre-design out. So the client is Hong Kong International Airport Authority. The architect was ADAS, and the consultant engineer, lead engineer, is AECOM. So our involvement on the project initially was a collaboration through our design for structures team, where we were doing steel to steel and concrete to steel connection design. It was something that AECOM didn't have the capability to deliver in-house, and they very much wanted a manufacturing level of knowledge in order to steer the design down that route. So very much since day one, they've said they want a manufacturer-led design intent, and clearly architects and engineers in the main don't have manufacturing experience, which is why we got pulled into the project, because clearly we do. That's the area of the market where we sit. So TDS were appointed to basically create a model. So this is the GTC roof. This is one of the smaller roof structures that we've designed out. And we were basically appointed as the specialist 3D structural modelling team for the project. So IFC files were issued from the architect and the engineer, and our instruction and our scope was to basically challenge the design that AECOM and ADAS had come up with, but from a manufacturing perspective. So really take on board the role of the steelwork fabricator, the company that's going to actually manufacture and install this steelwork. You know, why have they used a particular section size? Why have they used a particular splice detail? Why have they used a particular set of connection parameters and principles? So really digging into making sure that this is designed with the manufacturer in mind. And what we've ended up with, which is the fly-through that you're seeing now, is a fully connected LOD 400 model created in Tekla. It's been fully geometry checked by ourselves, by the engineer, and by the architect. We created a paperless workflow, so all of our RFIs and technical queries were raised in a system called Trimble Connect. So we had basically had a sort of to-do list. So rather than raising a formal RFI, you raised an issue on a to-do list. And when you click on that item, it takes you to the area of the model where the problem exists, and you can review that issue, you can walk around it, and you can come up with a solution. And crucially for us, what was absolutely innovative and collaborative about this workflow was that there was no design liability on us as a business. So the airport authority feels so confident that this workflow exists that they didn't feel that they needed to put any design liability on us for the area of service that we were providing. And that was really refreshing, because what that meant was, okay, we're going to find problems, there's going to be issues, but actually we're going to find those problems, we're going to find those issues, and that's going to help us move forward in a more constructive way. What we obviously ended up with was or will end up with is an aesthetically pleasing and very beautiful parametrically designed roof. What that meant was the client has received a number of benefits. So They've ended up with a digital asset that's been designed for manufacture and assembly. So the airport authority own the model, and that's then being able to create supply chain price certainty. So when they go out to their contractors at the end of July this year, they will be giving all of their steelwork suppliers the model. So those guys will be able to do all their material takeoffs. They'll be able to price very, very accurately. And as you mentioned before, Nick, they're going to be comparing apples to apples because, you know, clearly if they go out to 3 contractors, all 3 contractors will have priced to the same information. And so therefore they will have an expensive price, a mid-range price and a cheap price. They won't have 3 different prices, if that makes sense. What this has also created is it's minimized extra work orders and contract variations. So at the point where typically they would go out, if they were going out to their supply chain in July this year with architects and engineers information, those companies would have to factor in all the design and detailing, the development of the design, and you will no doubt end up with extra work orders and variations to the design. That can't happen now. So it's very much reduced in the risk of contractual conflict, because ultimately the fabricators are just going to be quoting to finite information with no design development, and they're just going to be able to roll their sleeves up and get stuck into manufacture, which is what they want to do. And what that also done is it's improved speed, efficiency and accuracy on the project. So because we've been on the project for the last 18 months, although there's been a program that we've had to work to, the program's been very liquid in terms of being able to move the program, because there's no site dates. In simple terms, I think the land that this airport is going on isn't even out to sea yet. So we're well ahead of the game. But what that's meant is we've been able to develop parametric modeling technology, custom components in Tekla, and we've really been able to really dig into the software that we're using, create script and code to enable us to design and detail the thing with a lot more efficiency and speed. And hopefully we'll be able to take some of those innovations into the core business onto UK-based projects. Again, the environment in the UK market just doesn't allow it. Everybody's just running around like headless chickens, trying to meet program, trying to keep jobs under budget, whereas this early adoption really enabled us to dig into improving the way that we work and speeding up the way that we work. And the other thing that this created was the potential for off-site manufacture. So we've looked at assembling areas of the structure away from site, so that less site works are required, and so that stuff can be craned in and installed a lot more efficiently. And again, that's particularly in the current climate where people are looking at MMC and looking at off-site construction as a way to tackle some of the UK challenges around sort of modularising and standardising projects. But absolutely, while this isn't a modular project, as you can see, it definitely created more of an off-site. What can we manufacture? What can we install away from site in a safe condition, and then obviously take it to site and crane it in. And that's pretty much it. So happy to take any questions, or obviously I think there's going to be a Q&A potentially at the end of the event. So if anyone's got any questions, feel free to fire them at me, and I'll do my best to answer them.
That's great. And there's 2 ways people can do that. They can either put them in the chat on the webpage they're looking at, and we'll pick those up in the Q&A you mentioned there, Daniel. Or alternatively, you can join live to the Q&A and ask a panel question to the panel, either via chat or actually physically asking it to a panel member. Look forward to your questions, and Daniel, thanks very much for your time.
Thanks, Nick.
Thank you, Daniel. Again, another very interesting interview there. If you'd like to ask Daniel a question in the live Q&A session, please use the Q&A function below, and we will put these questions to them at the panel. I'd now like to introduce Regan Cook, the Marketing Manager at Sapphire Balconies.
Hello, and thank you to Nick and the team for having me on this event today. So what I wanted to do was run through a couple case studies really showing how MMC has been successful on a number of our projects. So firstly, we're going to begin by looking at Pomona Wharf, which was a project in Trafford in Manchester. The second will be Trinity in Salford. Both were MMC projects, and we're going to really run through their challenges the delivery of the project, and then also the common success factors of both of them, and kind of how we can use modern methods of construction to on our projects in the future. So the first project is Pomona Wharf in Manchester. It was built using modern methods of construction, with all the wall panels being manufactured off-site with an RC frame and then simply installed on the building. And the key requirement for us on the project was fitting to the short program to help reduce the costs of the balcony install. What was the challenge on this project? So each day of crane hire was a direct saving to the client. And so it was key for us to fit with the short program to reduce the cost of the install. So what did we do? Balconies were stored off-site and manufactured off-site ahead of delivery dates, and then were able for cool off to site when they were required for install. So ahead of the big days of install at Pomona, we would get a flow going of deliveries to ensure maximum use of the crane. And this really enabled us to keep on track with the install on the day. We were able to install 23 balconies on the first day, and then in the second day we did 34 in just 6 hours, and this was a record on number of balcony installs in one day.
With all elevations now ready for balcony install and Sapphire having already made and stored all balconies, Sapphire transported over 50 balconies to the site. After a successful first attempt, 23 balconies were installed in a single day. On a sunny day in June 2017, a mobile crane returned to the site, firstly erected at a position behind one block to finish its facade before moving to a second carefully selected position, enabling balconies to be lifted straight into final install location on 2 different elevations of a second block.
As you can see,
with balconies already on site, pre-assembled and pre-slung, ready for installation, site teams get in position to start. Once in position, internal install team members set up Sapphire's unique safety door guard before opening the sliding doors. Once exclusion zones are set up and slingers, supervisors and installers are in position, each balcony begins its final journey. Safe transit of each balcony is made with the installers keeping close radio communication with each other. Once lifting hooks and guide ropes are connected to each balcony, slingers stand back. Once a balcony is at its correct height, installers can easily guide it onto its arms. Once square, it is brought tight into its final location by internal installers safely behind Sapphire's door guard. Once in position, the balconies can be secured to the arms with fixings which are tightened from above. When complete, all lifting straps are removed and carefully returned to the ground level, ready for subsequent balconies. With the crane set up in its second lifting position, more balconies are installed at a steady pace on the next 2 elevations. Despite only having been able to start at 9 AM, having moved crane positions and having a half-hour break for high winds, our 23rd balcony is craned into position after just 5 hours of balcony installation. Passing all expectations, site installers were on a roll and managed to smash all previous records by installing 34 fully assembled balconies in just 6 hours and 13 minutes. Using a 3-man install team, a single crane and 2 different crane positions on site. That's an amazing install average of just 10.9 minutes per balcony all day long. Sapphire's supply and support approach meant balconies were ready and right, enabling installers to achieve record-breaking results. Combined with a previous 23, Pomona Wharf had 57 rigid balconies rapidly installed in just 2 days.
So as you can see on that video, one of the key things was the good logistics and good coordination between the project team and Sapphire. Also, obviously, the balconies were manufactured and stored in advance off-site, enabling balconies to be cooled off for delivery when they were needed on site. There was also a sizable laydown area within the site because of where it was, which enabled us to actually deliver more balconies there at a time, enabling them for a quicker install. As we saw in the video as well, the crane was moved across different elevations in the same day, and the speed of install was limited as well because of the wind, but we still installed that record of 34 balconies in 6 hours. On the Right here we have an image of the anchors waiting for balcony install, and then also on the left you can see it there as well. Trinity on Salford. So this project is a high-rise residential scheme made up of about 380 apartments with communal facilities. The space between the buildings is supposed to be a bit of an urban orchard, and it does include on this scheme the Grade 2 listed Blackfriar pub as well, which is the common entrance to the project as well. So what was the key challenge on this project? The main thing was the use of the concrete wall panels, specifically in finding a way to fix the balcony arms to the panels while ensuring that the rigidity of the balcony met our Rigid Ready Right brand promise. The other challenge on this project was working with the concrete wall panel install schedule during the week while keeping the project program on track. Cast-in anchor brackets were designed into the wall panels to allow the arms to be fixed without any connection to the slab, and by successfully doing that we were able to avoid the need for any costly thermal breaks and penetrating the fire barriers. That also then eliminated the need for any fire stopping around the balcony brackets. The custom designs were shipped to customly designed brackets were sent to the manufacturer in Dublin, the precast manufacturer, and then sent from there to site as needed. Again, what was done here, so there's good collaboration between the project team and the Sapphire Logistics team to really ensure a continual sequence, as well as the precast manufacturer. Storage was off-site, and the balconies were enabled for off-site sort of call-off to site when needed. And again, there was a flow to site that was made a consistent delivery when we were doing big volumes in one day, which enabled us to maximise the install rate. And again, not quite as good as Pomona Wharf, but we managed to do 136 balconies in a week on this project. What were the key successful factors on the Trinity project? So the good coordination, again, between the logistics teams of both parties on the team and Sapphire, as well as the precast panel manufacturer in Dublin. The balconies were also designed with logistics in mind, so they were designed to fit the lorries in width, which meant more balconies could be put on per lorry load, which really optimized the loading and made it really efficient for deliveries. Again, the manufacturer and storage was off-site in advance of delivery dates. So what are the key successes between these two projects? Or what do we recommend, especially when using MMC? Really engage in early design discussions with your balcony manufacturer, whether it's Sapphire, whether it's someone else. The balcony manufacturer, especially around the connections, is going to want to have some input, and it ensures that the balconies are rigid for the residents. Great logistical coordination between the teams maximizes the install flow and enables you to install more balconies in one day. Design your balconies with logistics in mind. Enable and optimize and efficient loadings for deliveries, which will make it easier and quicker to get balconies to site and installed. Manufacture off-site and advance of delivery dates. This improves your quality of your balcony and reduces the risk to program delays. Our Rigid Ready Right brand promise is here to support you as well. So we promise and guarantee that every single one of Sapphire balconies will be rigid, ready and right. Rigid, we promise that every balcony using Sapphire anchors will be rigid and can scientifically be proven to deflect less than half the British standards allow. Ready, we promise that every balcony will be ready before the agreed dates. And right, we promise that to have traceable proof that each balcony has been inspected to the required standard so that every balcony is delivered right and snag-free. In closing, MMC is becoming more and more common across the industry. We see it and we hear about it a lot more often than we ever have. Following some UK research we did, we found that 73% of the construction professionals we interviewed said they were extremely open to working with modern methods of construction. However, it's not being taken up and embraced on actual sites. We need momentum to keep moving this forward. So to try and understand how MMC can be embraced, we asked a number of industry professionals what their driver to use MMC was, and they said 1 was quality, 2 efficiency and cost, and 3 industry trends. As more people move to modern methods of construction, more people will join and design that way. This kind of leads me on to the sort of conclusion of this is COVID and what we've experienced earlier this year really the opportunity to grow this momentum on modern methods of construction? Can MMC and offsite construction help us make the rest of 2020 and 2021 a success? Because modern methods of construction really reduces project programs. It increases your quality insurance, reduces costs, reduces risk, and minimizes storage on site. It could be an answer to some of the struggles we're facing at the moment due to COVID. I wanted to say thank you again to Nick and the team for having me on here, and to all the viewers to enjoy the rest of the event.
Thank you, Regan, for a very interesting case study there. If you'd like to ask Regan a question about this case study on the live Q&A session, please use the Q&A function below. I'd now like to introduce Laurie Pomry, who's a sales manager at Duty Point.
Hello, my name is Laurie from a company called Duty Point. I've been asked to speak today about off-site manufacture pods and present a case study. So a bit of history on Duty Point. Duty Point was founded in 1976 under the current ownership since 1995. Traditionally, we started as a pump distributor, selling to smaller pump distributors and motor rewinders and repairers across the UK. In early 2000s, we started manufacturing cold water booster sets, and in 2005, we were the first company in the world to get RAS approval on a full booster set. We are widely known as a cold water booster set and pump system manufacturer. So in 2017, we started manufacturing packaged utility rooms, and this has now become a key part of our business. So our purpose, why we get out of bed in the morning, is to reduce construction complexity by creating off-site packaged solutions to setting the bar in customer experience and innovation. I'd like to hone in on the reducing complexity and customer experience, as these are 2 points we are very, very precious about. So today I'd like to talk about a project called Prince of Wales Drive. It's a Barclays project for 394 apartments. We've recently delivered our first lot of units. So here are the units. They're 1200 wide by 780 mil deep. These units are ready to go out, and as you can see, they have protection at the side frames. We've actually fitted temporary lockable ply doors for extra protection. The key components within the unit are the heat interface unit, a tenant valve and water meter assembly, the consumer unit, underfloor heating manifold, provision for an electric meter, a box for your audio, your heating controls, a 6-gang grid switch, an LED light and PIR sensor. The unit has adjustable feet and a removable transport bar. Once the unit is in position on site, the screed will go into the unit. There are also wheels inset into the frame to move these units short distances into the final position, and fork pockets for moving the units with a forklift. So there's two main areas I want to concentrate on today. One being the importance of upfront thinking, and the other being how you must identify pain points, and if possible, reduce them or even get rid of them. So on to upfront thinking. The schedule is one of the things you must put time into upfront. So can you actually deliver the first lot of units on time, and then can you meet the program through the project? Prince of Wales Drive was very, very tight. We ended up with only 4.5 weeks from design freeze through to delivery, which was a massive challenge. The only way we've managed this internally is to set key milestones for everybody involved and get the team together on at least a weekly basis to hold each other accountable. I'm pleased to say we hit our first delivery on time. The other item you must put upfront time into is making sure that you've got every bit of equipment included early doors. This is a challenge, but it is not always easy to get this up front. Logistics to site is another item you must think about early doors. We were presented with a fairly major challenge on this project. They wanted these units delivered on their backs rather than vertically like we would normally supply them. When it came to loading them onto a truck, this meant we could get only half of the usual delivery. We've come up with a method of double stacking these, which has enabled us to carry out normal delivery sizes. If we had not thought of this early doors, it would have been a major problem to us later on. The other thing is the actual offload and final positioning. How the unit actually comes off the truck and gets to its final position. Again with this project, because it was coming on its back, it was a major challenge. We set to, and our innovation team had come up with a unit to flip the trolley from horizontal to vertical safely on site. I'm going to show you a quick video of this now. So as you can see, this is a very safe way of flipping units on site, and it's been a great success. The other item you must think about up front is project-specific QA and testing. On Prince of Wales Drive, the client actually visited us on 2 separate occasions, and we went through the QA in great detail. And testing. What standards do you need to test this to mechanically and electrically? This can obviously vary per project. So to go on now to identifying pain points and reducing them where possible. It's actually key you do this for a smooth delivery of the project. One of the items which is always a big issue is free issued equipment from the customer. This needs to be well managed. If it's not well managed, it will let you down on the schedule through the project. The other thing that needs to be given great thought to and is often left is how the unit integrates with the building. So how it actually fits in with the door frame, etc. There's no way around this than actually thinking about this up front. One big pain point on pods in general is leaks. This is a massive challenge, and I believe that it's one of the biggest challenges that developers face on off-site manufacturing. We've invested in a CNC pipe former to try and reduce these. I was going to show you a very quick video now of it running. Investing in this machine has enabled us to reduce the risk for leaks. On one particular project, we actually took out 24 elbows, which is 48 potential risk points. It's actually leak prevention rather than leak reduction. Schedule changing is also a massive issue when it comes to manufacture of pods. This isn't as easy to manage as it would be if you were building traditionally. We've now insisted on a 2-week window where we cannot change the schedule unless something catastrophic happens. So to conclude, if you're doing off-site manufacture of pods, you must put sufficient upfront thinking. It will go wrong if you don't, and you must identify the pain points, reduce them, get rid of them if you can. Thank you very much. Have a good day.
Thank you for a very interesting presentation there. If you'd like to ask Laurie about his presentation and you have questions, please put it on the function below and we'll put it to him on the panel. We'll be now having a 10-minute break. When we return, Nick Horton will be presenting a CPD on balconies made rigid, ready and right.
As an organisation, we're simply asking for all buildings, all apartment buildings, to have non-combustible facades. Our fire team is considered quite radical in that they have a lot of traction within our organisation in terms of reviewing balcony construction in particular, trying to future-proof our schemes.
I think the round table is a way forward. At the moment, there's a big conversation about fire. There's a multitude of different events talking about fire and talking about how buildings work and the risk to high-rise buildings specifically. We're getting better quality information back to each other. And I've learned a lot this morning from different providers of what we possibly could do.
The roundtable's always very interesting. You've got the manufacturers, insurers, architects, you've got fire and rescue services. They all bring together a whole different series of perspectives. And only by actually trying to understand how everybody else in that particular contractual chain, the issues that they face and what they're doing and how they're going to resolve it, can you then give you best advice and best understand all the issues that are out there.
Very knowledgeable presenters today. Really good product knowledge, really good knowledge of the change to the building regulations. It's been very informative.
Just the emphasis in terms of how much fire and fire safety plays in the part of design, just coming in today gave us a far deeper understanding of it. Just having the other professionals to bounce ideas back from has been helpful, understanding their perspective and knowing that actually we're all working for the same kind of goal.
Very knowledgeable presenters today. Really good product knowledge, really good knowledge of the change to the building regulations. It's been very informative.
I've been many workshops and seminars. It's well organized and it was very good. So I recommend it. It's a very good thing.
The way that it was presented and the language used was in a format that I was able to understand, so that was really beneficial. There's new things on the market that I wouldn't have known prior to coming here that I can, when I'm out on site, certainly mention those to the estate managers. The environment was comfortable, relaxed and enjoyable.
Just the emphasis in terms of how much fire and fire safety plays in the part of design, just coming in today gave us a far deeper understanding of it. Just having the other professionals to bounce ideas back from has been helpful, understanding their perspective and knowing that actually we're all working for the same kind of goal.
Where I think we need to focus our efforts now, and indeed we are focusing our efforts, is improving the collateral that people can have, the advice that people can get for installation, and some kind of assistance with QA to make sure that the products that they're buying are installed in accordance with the recommendations and they're fit for purpose.
My role is to come back out to the market and say what you've built isn't compliant and help the industry then come to terms and to find solutions to correct those deficiencies. The change is that now we have to be a lot more practical and a lot more strict. So whereas before we can navigate somebody through the situation and go, it's not compliant, we can do something to make them compliant. Now having to say to them, actually not compliant in 4 or 5 different levels. And that's the change, really changed the way that we work as a company.
We've taken the view that as a business that we offer a fully tested system now, and we're trying to drive the market forward, that everything we do in the structure is completely tested. As a business, we've gone through the process of reviewing what we do and making it easier for architects to specify. So within modern construction, you see a lot of people using boarding solutions and saying they have test evidence. And we've actually made one particular product, we've branded it uniquely, so we can control the supply of it, and it comes with full test evidence.
As a trade association that works in the passive fire protection industry, we are trying to make sure that our members are fully up to date with regulation, and that what we're trying to do is make sure that the regulation is evolving, meets our members' needs, and ensures the delivery of the best practice of the installed passive fire protection. Both making sure that we've got products that are out there that are properly tested and certified of performance, and then the installers take those and use those in the appropriate manner to deliver the best and safest possible built environment.
Well, Baltimore Tower was quite a unique project, and we worked closely with Sapphire to develop designs that were unique to the industry to overcome health and safety issues and install procedures. Initially, we started off with Sapphire as a balustrade installer, installing various little projects around the country. Over time, the relationship grew. It's probably been about 8 years now, 7 or 8 years we've worked closely together. In 2014, Sapphire then had the confidence to give us an opportunity to price their biggest job to date. And then from that point forward, we've worked closely with Sapphire. Now, as they've moved into balconies, we've been able to support their growth in this sector. Fortunate enough, we was involved in the first ever balcony installation for Sapphire, where we installed 22 balconies in a day. It was a very unique situation, and everyone pulled together and delivered exactly what was expected and what we set out to do. Following the successful completion of Baltimore, we were then fortunate enough to land a project in Wembley called NW06 Alto. It was a weights project that Sapphire was supplying the balconies on. There was approximately 400 balconies throughout the project on various size of arms. The installation went very well. We completed the project on time with no issues. All snags or quality issues that were found towards the end of the project were dealt with smoothly. I believe the customer have good reports on how they felt it was, and we have recommendations for the exercise we undertook. A unique thing about Wembley NW06 was some of the projections of balconies were around 2 meters. It's to date the largest depth balcony I've ever installed, and it was quite remarkable how much they didn't deflect compared to balconies I'd fitted previous to this date. The balconies ended up being solid, of a good quality. Over the years, I've installed many balconies, the old style bolt-on balconies. We used to, as a company, achieve a couple of balconies a day from start to finish as a completed project. With that, we also encountered safety issues, manual handling, damage to products, whereas with the glide-on system that we use here, we achieve much greater numbers. The safety is increased because of not having to work on the scaffold. During some projects, we've found that sequencing has to be changed and we have to install balconies under balconies already fitted above for varying reasons. With the counter-lever arm, this is easily achievable with the Sapphire system, which allows us to be more flexible around program and situations that occur on site. I think between Sapphire and Steel Build, we have a great respect for each other's company. When there are issues, we speak to Sapphire. Sapphire trusts what we say and our judgment. Sapphire then react to what we say in a fair manner. So throughout the process at Wembley, even though it was a vast job, any issues that arose, everything got dealt with in the correct way, whether it would be us through Sapphire or through Sapphire for themselves to deal with the problems. So there was no prolonged periods of disputes going on. For me as a managing director and an employer of people, they make it easy for me to write risk assessments. The install sequence is smooth, and also the quality of the product is very good. The kit comes in its complete entirety every time, comes with a checklist. The equipment's always in date. The balconies are always of a good standard, and on the very exception that they turn up with an imperfection, they're dealt with instantly. And one of the things within our system is we check the balcony on delivery, so we check it for damage. Balconies 99% of the time are fine, and they get lifted up and it gets documented and it's just a signature. On the rare occasion there is an issue, we report this direct to Sapphire, and Sapphire deal with it in the best way possible. I believe Sapphire and Steel Build have a close working relationship, and I believe personally I have a close working relationship with individuals within Sapphire also, which always helps when overcoming problems. And I think in business, the best thing to have between two parties is respect, and I believe both companies respect each other for what we know. 100% I trust Sapphire. I believe Sapphire are a market leader in balconies. As I say, I've worked for many companies over the years, and since the glide-on system, I think it's taken the balcony development into a whole new era. So health and safety, speed, practicality for site, I just believe there isn't anything in the old model that even competes.
Welcome back. I would now like to introduce Nick Horton, our marketing manager at Sapphire Balcony.
Good, well, welcome everyone. I'm Nick Horton. I've been working at Sapphire for 14 years now. Today we're going to look at balcony design. We're going to look at some of the common issues that have been, and look at some of the things happening at the moment in the industry. We're going to take you on a bit of a journey through that process. We're going to look at lots of different areas, but if there's a particular area you want to ask some more questions about, feel free to. We can go into that in a bit more depth. So today, firstly, we're going to explain a bit about the past in balconies. We're going to look at what the challenges have been in balancing balconies, install challenges, fires, and so on. We're going to look at what is happening right now in terms of the new regulations around the fire side of things. We're going to look at the new British standard, which you may or may not know about. And lastly, we're going to give a bit of an approach for the future. What I would also say is we also run a event series called Resi Build. There's a separate website, resi.build, where there's a whole host of other topics you can learn about from lots of different speakers, not just about balconies. We'd recommend you go on there, have a look at other forms of learning if you're wanting to know a bit more about some of the other series which are happening at the moment. The next one is a debate on laminate glass, a live debate with several different speakers, and that's in a few weeks' time. So if you want to book on, go to www.resi.build. But in terms of balconies and the Sapphire experience, we originally established in 1992. 2006, we moved out of London, which is where we originally were. And during that process, we were very much based around making the kind of pretty bit of the balcony, the balustrade only. We were doing staircases, we were doing lots of retail stores all around the country. And with that, we, in 2009, started naturally getting pulled into the balcony market. And the reason for that was quite a distinct change, is that people started to move away from concrete balconies, realising the hassle and the difficulties with coordinating lots of different trades and bringing it into one package. And so back in those days, if you were doing a metal balcony, predominantly it would have been one company doing the steel work, one company doing the balustrade, one doing the drainage stuff, one doing the decking and so on. Much of the way a concrete balcony is done now. But in 2012, that changed quite distinctly, and we'll show you a bit more about that as we go through. So to give you confidence, we're approved details of Premier Guarantee, NHBC, We also sit on the British Standard Committee, who have written the brand new standard 8579, which is due to come out in August this year. It came out of consultation at the beginning of this year. We also do a lot of work with people like Exova or Warrington Fire, as you may know them, who specialise in fire and buildings. So one thing to be aware of is all our balconies come with a 3-part guarantee. The first part is that they'll be rigid, so we'll touch on this in a bit more detail a bit later on and show you the importance of that and also how you can optimise your anchors for that. We believe that a balcony should be ready ahead of time, and that when it does come to site, it's like a car. You wouldn't expect a car to come without some of the components assembled on it, and we believe a balcony should be made the same way. So we manufacture in advance, we store them in secure locations, and we guarantee that when they get to site, they'll be right first time. If they don't fulfil those 3 criteria, we don't just solve the problem, we also give £100 back per area per balcony, to make sure that it's a catalyst of self-improvement internally. So the point being really is that we strive and focus on these parts here throughout the company, so we don't actually get it wrong and don't have to pay. So some of the schemes which we've worked on in the past, this one here was one which shows a few of the reasons why developers engage us. This was one in for O'Shea, a Galliard's home development in North London. And this was basically, there's 2 parts to this one which they were particularly concerned about. One was that the planners are very insistent on this timber look which had been submitted. So we created a wood effect veneer, a bit like a table veneer, but this one was actually out of powder coating, so it had an aluminium core and it wasn't going to rot over time, which is what the developer concerns were. The second thing was the curved area there had a lot of rebar, and they wanted to minimise the conflicts between the balustrade fixings where they're drilling into rebar. So we created jigsaw puzzle templates so they could join into each other all the way around. They could be optimised in the design office, laid out on site to grid lines, and minimise the amount of conflicts. And so they took us on to the next scheme to apply those same benefits there. The scheme is called Baltimore Wharf. This is the tower here. We've done a 20-storey block behind that as well. But the tower is the shape of the human eye. It's like an oval shape, and at the extent you've got these glass floors to them, 3.6 metres in length. You've got these big balconies around there. You've got over 10,000 glass panels on the balustrade alone. And each floor is rotated 2.5 degrees to give it quite an iconic twist to the building. So each way you look at the building, it's different shape, which looks quite neat. But likewise, it's quite a difficult logistic challenge for actually building it because you can't use mast climbers and those sort of things because it's curved building, it's twisted. So one of the key things they needed us to work with was to actually cast in advance. And so out of these fixings, and there's over 380,000 fixings on that scheme, not a single one of those was actually drilled on site. They were all cast in ahead of time. And as you can imagine, that was very much front-loaded in that design process. And then it was much more efficient in the build. And coupled with that, we also then created this shroud around the building, this white area you can see in these pictures and what these people are working behind. The point of that was that could shroud the whole building, it could climb up floor by floor as you go up the building. And it was protecting people, so it didn't have to work with harnesses, it didn't need scaffolding. And likewise, it also meant that the wind wasn't so much an issue with installing those balcony balustrade panels. You can imagine if you're pushing a big panel out 46 stories up in an exposed location like that, there's a lot of wind. Obviously, that was reducing that. So they were installing one floor every 2 weeks, all the way through the scheme. So it's a 2-year scheme. But more traditional balcony types we work on are kind of the projecting cantilever balconies like these. We do a lot with the likes of St George. This is a scheme we've done. These 2 blocks here, we've done the block where that red crane is, and we're just currently working on ones where the white crane is there as well. So this particular scheme here, this is one on the Greenwich Peninsula for Night Dragon. And the reason this is quite an interesting scheme is because their intent was to create quite a different variety of buildings, and they're all in very close proximity one to another. but they wanted to make sure that they had the ability to change the aesthetic style of that from one balcony to other without actually having to redesign the anchors, redesign the drainage methods and all those sort of things. So what you'll see in these next slides is a load of balconies which look quite different, but actually are very similar behind the aesthetics. So you can see here some vertical bar ones with some white solid walls, one elevation, glass on the other elevation. You've got this one here which has got like a facade I-beam type effect on the balconies. And they're also in a bronzy kind of gold colour anodized. Then you've got a variety of other different balconies all the way down those elevations. We are going to concentrate on rectangular balconies. They don't feel limited. Schemes like this one here in Reading has balconies wrapping around the outside of the building. It also has some very intricate dogleg shaped balconies inset into the building. And actually inset balconies can often benefit the most because it's much more cost effective. You've got a lot more thermal savings and so on from using bulk metal balconies. So we're not really going to touch on Juliet balconies today. Terrace balconies, inset balconies and projecting balconies. We approach all those three as a cantilever structure supported back from the main entrance where normally the doors be on the balcony. So a terrace would just be a series. It can be applied like that onto an existing building. It doesn't have to be a new build, although predominantly what we do work on is new build. So do any of you happen to have actually seen a balcony being installed before? Not too sure if anyone was trying to speak then, Matt.
Yeah, no, is a simple answer.
Okay, fine. We'll talk you through the process then of balconies. Traditionally, this is a job we did back in Battersea in 2009. So this is connecting to shock anchors in this particular scheme. And you're bolting onto them from the bottom, working from the bottom upwards. And the reason being is that you need to access those bolts. And then you stand on the next balcony up to access the one above that. So this is a picture of the install. So swinging balconies in. Average balcony and a steel balcony would be around 2.5 ton once it's got the soffits on there as well. But that's being pulled into the building, guided by the people below, and bolted on for working way out the building. Because it's quite difficult and there's not much tolerance with those lining up two holes and getting a bolt through, it does become quite slow. And as a result, we're installing around 4 to 6 in a day on average. And this is pretty standard for a bolt-on balcony. Still much quicker than you can complete a concrete balcony in. There's a drilling alone of concrete balconies. So the balustrade fixing is quite a time-consuming process. Sorry, it seems to have frozen in a second. So we moved away from the concept of bolt-on balconies and moved to glide-on balconies, and the reason for this was twofold. First thing is that we're finding that quite a lot of the of bolt-on balconies we're connecting back into the building on end up feeling fairly flexible, even though they're completely within the British Standard and Eurocode guidance. They still felt flexible, and this was obviously leading to end users feeling unsafe as well. So that's a deflection at the end of that anchor we're talking about, the end of the arm there. So the first thing we did was we created a two-part system. So the first part here is where you've got cast in and the arms coming out of the building. And the point of that is that you can slide on a separate section, which gets clamped afterwards. And the two main benefits here, the first one from a strength point of view is that you've not got a back member to that balcony which is flexing and causing the whole balcony to flex at the end. That is taken right back to the slab edge, which is the best place to resist forces. And the second thing was that you didn't need to have that access underneath to line up holes. It gives us much greater tolerance, and likewise it enables the balconies to be installed without people underneath. So much better from a health and safety point of view. Very first scheme we installed 22 in 6 hours. So you can see the vast speed difference there. and we've installed 36 is our record, but installed over 20 many times. And this is basically because it's taking an online process which is quite time consuming on site and doing them simply in a factory. So soffits, for instance, on a site, previously they used to have a bad reputation of being quite costly because you've got two people, one holding it, one fixing it through as you're working up the building. In the factory, you can turn the balcony upside down, and it takes about 10 minutes just sliding a balcony and riveting it on for one person. So it goes through a process which is about 3 hours for two people to 10 minutes for one person. It's a lot more cost effective as well, obviously. So I'm going to show this video which will hopefully give you a bit of an insight as to the whole process. This is a scheme in Southall. So get on to some of the more specific points of this. Firstly, it does enable either a top-down or bottom-up approach to installing balconies. So it enables you don't have to work from the bottom upwards like you do on a bolt-on balcony. On taller schemes like this one here, it can be an advantage because they don't have to strike all the scaffolding in one go. You can install it from the top down if they need to. On this particular scheme, there was some issues with some of the doors. They couldn't release the whole elevation they planned to. So we're only able to release a few, so it meant we could kind of infill just a few of them. But obviously, if you're installing top down, you need this counterbalance attachment, which is something which we've got a whole fleet of these to offset that crane hook and take it beyond the line of the balustrade. MMC becoming very much more common, especially up north, Manchester and so on, and in Ireland. One of the things which is, well, there's 2 points really on MMC schemes which are quite key. The first one is that a lot of MMC schemes aren't able to give the same strength as an RC frame would. So connecting to an outside concrete precast wall panel or connected to light gauge steel, CLT, all these sort of solutions, we have connected to all of those, but all of them in common don't have the same strength. And therefore, using a lightweight aluminium balcony actually takes our weight from around 2.5 tons to about 700 kg, so 0.7 of a ton. So there's quite a lot of weight reduction, and that makes a big difference to the balconies and those sort of schemes. The other thing with MMC schemes is we tend to find, in the main, they don't have a dedicated site crane or if they do, it's quite tied up with bathroom pods and other craning in other panels and so on for the facade. And with that, the install speeds are quite key. And this one here is one where we installed the first 24 balconies in one day and the next 34 the next day. And that was moving the crane around site on those days as well. So it's quite key that on a scheme like that you minimise the amount of crane time needed. It may be for the benefit of other trades, but on this particular scheme, every day that crane was on site was a cost. So every day we were saving off the programme was a direct cost saving of several £1,000s. And this is one of the ways which QSs and so on can make quite a big difference to their balcony packages, actually by planning it right, so they can use the crane for the minimal amount of time and save the most amount of money. And last but certainly not least, people are all within the building, so they don't have to be underneath to line those bolts up. Much safer than having a moving load above somebody's head. Sometimes you need something slightly different, and this is what was needed in this particular scheme here. This is one in Woodbury Down, a Barclay scheme, where we used a roof crane. Now, the point of the roof crane was basically that they could install this whole stack of balconies way after the crane had been struck, the tower crane. So they were saving the money on the tower crane, but the reason they couldn't install those before the crane went was because that's where the goods hoist location was. So they wanted to take all the bulky equipment up to the apartments in there. So we waited for the hoist to come down. We could take this cantilever roof hoist up in small pieces inside the internal goods lift, assemble it on the roof, and then install those 30 balconies. So we can go now on to some of the technical detailing of a balcony, the first part being the anchors. So the anchors, we're going to concentrate on the RC frame stages purely because it's most common. The second part, the thermal brake. And the third part is a 1 or 2 piece arm. I'm not really going to spend much time on this today. 85% of balconies we do are in this kind of location where you've got two pieces, this sort of scenario. And the point of that is that if you have a 1 piece arm coming out, it can be cheaper, but it can also be a bit of a pain for scaffold lifts and all that sort of thing. So it generally ends up being a 2-part install. So they fit the second part as you're coming down the building, and the scaffolding's being struck. So the key thing to get right here is rigidity. If you don't get the rigidity right, it's A, very costly to put right, but B, it forever causes a problem with resident complaints and so on. Often the rigidity and the thermal performance will actually fight against each other, because obviously the more metal you've got in something, the stronger it is, but also the worse the performance is. We'll show you how to balance that. And thirdly, it's really the simplicity to cast in, because that's where a lot of the tolerance challenges used to come from in the days when we did bolt-on balconies. So, does anyone know how much this balcony here would actually be allowed to deflect? Does anyone know what the Euro codes require? No? Well, sorry, go on.
No, I don't. No.
So the length of a balcony and any cantilever structure is allowed to deflect to the extent here of the length divided by 180. That's the formula to use. So putting that in simple balcony terms, often the cavity is about 300 mil from the slab edge to the outside of the facade line. Going from there to the inside of the balustrade, normally it's 1.5 metre turning circle for a disabled user. So adding those together, you get 1.8 metres. Divide that by 180, you get 10 mil of movement at the extent of that balcony. And our belief is that on a 1.5 metre balcony feels small. To get 10 mil of movement on that is quite a major amount of movement. And this is why those complaints are there, because it may be only moving 4 mil. It might be far inside those Euro codes, but at the same time it feels flexible and it doesn't feel safe. So what we've been looking at is how can you minimise that? It's basically by addressing the way the moment force is dealt with. So the stretch at the top bolts, and the bottom bolts, we don't need to worry about stretch, you've got the compression. So the first step of that is to actually get a much more rigid anchor. And this has got other benefits as well, one of which is the fact that by having a stronger anchor, you need less anchors. Massive cost saving. Also, we'll touch on it from a thermal point of view in a second as well. So the first thing we've done to the anchor system here is we've increased those top bolts from an average M18, M20 or M22, which are the common size in the marketplace. We've increased those to an M30 diameter, so quite a chunky anchor at the top. That really does reduce the stretch. That's a stainless steel bar, stainless steel because of corrosion, but also because of the fact it's much better thermally than galvanized mild steel is. Second thing we've done is spaced out the horizontal and vertical spacings of the I-beam, of the bolts there, to enable an I-beam to be put in the optimal position. Now this can make it much simpler to achieve a level threshold and so on, but ultimately the strongest place is between those two sets of bolts where it can resist to the maximum. The third thing we've done is split out the thermal brakes. The bottom bit there has got a compression plate, so it's normally like a Farrex type material we use. And at the top there, that we used to use polystyrene, that most people did, and we've changed that to a mineral wool. That is obviously voluntary because that is actually exempt in the fire regulations, but we do still think it's a much safer approach. So we had a number of issues back in the bolt-on balcony days, and this was one of the schemes which we've got a few photos of. Now, some quite horrendous issues here, some anchors casting upside down. Not really a reflection at all, any of this on the anchor design, but this was actually the casting basically. And so we looked at this and said, how can we quite regularly get a site engineer sign off an anchor as being within a 2 mil tolerance, and actually after it's cast, it's far outside of that. So we did a bit of a study on casting. What we realised is that actually a number of these anchors, people were stepping back as they're casting it and treading on it. So they might just dip in front of it, it might rotate that anchor and so on. And that's one of the first things we discovered, is that that's probably part of the issue in there. So what we've done here is not only introduce 20 mil of tolerance because you're starting an aperture over an arm rather than lining up 2 holes, but we use spacing templates to lock them or rigid, stop that rotation. But also, if somebody does tread on it, it's actually spaced off the casting table as well, which means that people can tread on it without actually damaging anything. So some of these things are quite simple to do, but they're quite imperative to actually make sure you're maximising the tolerance. As I touched on earlier, thermal, quite a complex area, but we've done loads of studies on this. We've actually got a specialist fridge for testing thermal connections on balcony slabs in our R&D lab in Reading. But one of the key areas to look at is less heat loss comes from less anchors. Less anchors, less heat loss, simple formula. But that also makes the whole water penetration and the fire stopping around anchor design and so on a lot simpler as well. So it saves a massive amount of cost, and it makes a lot of sense from a rigidity point of view, having stronger anchors and less of them. But thermal is one of the big areas of benefit. So not really going to go into the fire stopping in too much detail on this slide, but we've tested many different scenarios. If you do want information for a project, there is some available on our website, or you can download the fire white paper, which gives you an in-depth review of all the testing we've done, all the things we've found. But ultimately, there's 2 things you need to comply with. One is the 2-hour fire protection in terms of insulation, and one's the actual integrity of that. And that you only need to worry about behind the facade line. Outside of the facade line, it's all about being Class A. So we see on this slide here is what we call a stub guard. It's a simple solution for actually allowing in that spinal zone where there's quite compact and a lot going on there. You can bring your fire stop, your fire cavity barriers up into the fire stub guard around the anchor. What that means is that you can place that on, you can slide it back into position because it's a CNC routed item supplied from the factory. Is that you can't actually get upside down, and it's quite simple to interface with either a cavity barrier or a linear joint seal, like the right hand side of that one. Let's say we do other connections to the CLT example and there's many other solutions we've connected to, including existing buildings. Now going on to the cassette structure now, so we're working on. The first thing to get right is designing it proactively to resist fire. The second thing is drainage, and we'll come on to some guidance from the new British Standard about that in a second as well. So the decking runs parallel to the building. We're not really going to touch on decking today. If you want to know about decking, we recommend you get in touch with our preferred choice of decking, which is MyDeck, MYDEK. But from a fire point of view, you've probably all seen this document, and the point of showing this part here is one of the issues at Grenfell was the fact that above the 18-metre mark, the height of the building at Grenfell was, that should have actually been to a Class B, where it burnt like a C. Now at this point, balustrades and balconies were not actually included within the standard for fire, and there's a number of other exemptions as well. But even after Grenfell, there's been a number of different balcony fires, and we've done extensive balcony fire research. If you're wanting an in-depth research, if you go onto the ResiBuild, ISI.build website, there's a number of CPDs which we do on a monthly basis. First Tuesday of every month we do a CPD, and there are 2 on fire which we do, one about how to make a balcony fire resistant and one about these kind of incidents and so on from the research we've done. So feel free to sign up to any of those. But this one here was a chip pan fire, started on the 9th floor, spread out to the building and rapidly went down to the 8th floor and all the way up to the 14th floor. Now the 2 recommendations which came out of this, one was that the Manchester Fire Brigade recommended using metal soffits to deflect heat but also contain those embers, and also recommended designing out all the timber. That's obviously now mandatory and that's the height building. But this is part of what we found out during that research. When the Dame Hackett recommendations went out of consultation midway through 2018, and within a 2-week period, there happened to be 6 balcony fires in the UK, some of which were quite significant. This one top left-hand side was one West Hampstead, started on a podium level and spread all the way out the building, and that was a brand new building. Again, we've dealt with the London Fire Brigade, none of those schemes are ours. But we do a lot of work in London and Manchester and all the areas around. So finding out how things are happening, what the causes of them are and so on is quite a key area for improving balcony design for the industry. One of the differences between this balcony and the one at West Hampstead, which burnt significantly, this one here is actually one of ours, and this is where our balcony journey started into balcony fires. And this was actually before Grenfell, so by the time Grenfell came, we were already researching fire in quite a lot of depth. But what happened here is somebody was smoking on the balcony above, they flicked their cigarette off and it landed on the one below. That landed on a beanbag and caused quite extensive damage to that balcony. You can see the smoke damage to the one above, you can see the marks contained at the bottom there. But ultimately, the glass was smashed by the fire brigade, so they could actually spray the hose on. You can see where they've also straight cut those boards to stop it spreading further along. So really, this showed to us the importance of the role of soffits. This balcony here has a Class C decking. Class C is obviously now banned, and it had a Class A soffit. The only difference between this one and the ones which burnt considerably back in that previous slide at West Hampstead was that the ones at West Hampstead, they didn't have a Class A soffit, they had a Class C soffit. And that really showed us the importance of how fire spread can be limited by using soffits. Same with the Manchester one, really. Sorry, was somebody just about to say something? No. So looking at the timeline of the ban and what's been happening, the ban was obviously announced end of 2018. It lacked clarity originally, still does in a number of areas. Balconies have obviously gone into that, and the only exemption to that is gaskets and so on, and thermal brakes, which are needed for Part L. They applied from the 21st of December. And you may or may not be aware, but there's a few more changes in the pipeline now. There's a consultation currently out around laminate glass. Quite a topical question. We'll talk about that a bit in a second as well. But just for your interest, this is a video we did before the ban came in, actually. It shows the difference between the Class A, Class B, Class C, and Class D balcony. And it shows really the behaviours of how these different deck boards burn on a small sample of balcony. So you can see that basically it does make quite a big difference between the different boards. The Class B even was quite a lot better than the Class C. But our recommendation is that even if it's under the mandatory height, 18 metres at the moment, potentially 11 fairly soon, if the consultation is approved and like what Scotland have already done. But even under that mark, we'd recommend you consider at least using soffits, and also definitely going for at least a Class B if you're going to go for a combustible soffit. Our recommendation is always to stick with the aluminium. So moving on from fire onto drainage, there's generally been seen as two ways of draining balcony. We've got free draining, we've got pipe drainage, or positive drainage as it's commonly known. Now, some of you may have had had experiences previously within HBC around this. Their guidance has generally been the go-to for the industry because there hasn't been any British standards or any other guidance which has pointed people to how to drain a balcony. And even the NHBC guidance is really about concrete balconies. One of the things which they suggest is draining a 6 square metres should be drained as per their 7.2 pitch roof document, which basically says it needs to be water managed. So on the roof, that makes a lot of sense. So you're draining it to a gutter and then take it down a rainwater pipe. And that's the kind of concept here. You bring it back towards the building and down the pipe. Free draining is being considered to be anything outside of those parameters. So if you can drain it all the way through, or you've got perforated soffits, or perhaps you even need to take it to the front like this particular drawing. The good news with the British Standard 8579 is that basically they're actually defining those two categories into three categories. And the point being is that there needs to be a distinction between balcony where you are draining and when you're doing nothing at all too. So the easiest way to remember these three categories now is that basically the first one is if you had a cup of coffee, you poured it on your balcony, it's what would happen to one below. So below the balcony, if it was free drained, we'd end up with the coffee on it. On a controlled draining balcony, that would have been taken to the side and dispersed, or to the front and dispersed. You're doing something with that. It's not going to end up in the balcony below, except perhaps a couple of drips which blow back in or something. Pipe drainage, however, would take that to a rainwater pipe and down to the ground. Now, the interesting thing is that the recommendation of the British Standards is actually this middle category, not pipe drainage. They recommend that you should be draining a balcony to the front edge, and the reason for that is to drain it to the front edge makes more sense because you're taking it away from the building rather than taking it back towards the building, which is obviously a bad principle from a water management point of view. But they also recommend that you do it in compartments because then you don't have any build-up and concentration of water. Obviously, a pipe drainage system would need a concentration of water. You need to get all to that one pipe and then down. And that 6 square metre rule was debated at quite some length, and basically there is no basis for having that apply to stacks of balconies. Quite a different story when you've got it draining a roof, a pitch roof, and that makes complete sense for draining it to rainwater pipe if it's over 6 square metres. But you see these balconies here, and this photo demonstrates this point quite well, is that where that balcony was 10 metres square or 2 metres square, doesn't really make a difference. What makes a difference to all those balconies in that stack is where they are. So you can see there the top one's got a bit of water in it, the one below, tiny bit of water in it. And as you go further and further down that balcony stack, it gets drier and drier. And that's really the point, is that it's pointless of all those balconies being positively drained to a rainwater pipe, because ultimately they're being protected from by the one above. At this point, I've demonstrated this. You can see there's been quite a debate in the industry about how to drain balconies. You can see in practice it doesn't really make much difference between them. So moving on to looking at the balustrade detailing now, the third element of the balcony. The first thing to get right is the balustrade height, then the regulations which apply to that form of guarding, particularly this glass, and then the base fixing. So I guess some of you here probably know what height this balustrade should be. Who knows? So the balcony under BS 6180 and the Part K regulations should have a height on the balustrade of 1.1 metres. Now the point of it really is that it would stop people climbing over. And well done, Paul. We got it right in the chat, I've just noticed. The point of this really is to stop it from being climbed over. It's ultimately a guarding, stopping from a safety point of view. Now, this particular scheme, the reason we use this picture here is it demonstrates quite an important part to get right. This scheme here, we installed a balustrade originally. It was 1100 high, and they came and did all the finishes and so on, changed a bit of the design as it went, and ended up with the building control not signing it off because of the fact it was under 1100. Now, the reason for that could have been a load of different items. It might have been that they tried achieving more of a level threshold and so on. And it was only a few millimetres under 1100, but they would not sign it off. So on this case, they're quite lucky that they've chosen offset hammer, so we just extended those brackets, so we raised the hammer height. The point being really is that we shouldn't need to do this. It should really, if we plan it in from the start, and we automatically do on all our balconies, we add another 20 or 30 millimetres to the top bit. We just recommend doing that. The other thing to be aware of is further up the building, if you increase the height from like 1100 to say 1300, you can make a big difference to the usability of a balcony, because it means it's much more practical from a wind point of view as well, if it's solid like this. So a frameless structural glass balcony is one where the glass is taken below, there's no posts. And there's 3 videos here which really demonstrate what you need to do with glass. Now these are videos from back when we were promoting the use of laminate glass as a safe alternative from monolithic glass. So what you see here, these videos are about 12 years old. So you're smashing the most vulnerable point, it then smashes into lots of small shards. Theoretically, this is the whole point of safety glass, but believe me, they wouldn't feel that safe if you were showered from the 30th floor with that. And then the alternative to that is using an equivalent strength, 10 plus 10, with laminate glass. So this is smashing those 2 panels. The first one there has been smashed. You can see the benefit of using laminate glass. Now, as you're probably aware, laminate glass is no longer allowed in a balustrade because it's inadvertently been banned in the requirements for Part B. The document which was released had an exemption for laminate as used in a window scenario that didn't mention balustrades, and therefore has inadvertently been banned. Now, there's quite a lot going on behind the scenes. There is a consultation out at the moment. We've been doing lots of testing with the government and with fire brigades and so on. We did a quite significant balcony test, burning whole balcony, and seeing how monolithic and laminate glass performed in the same scenario, burning it with your wick chairs, bamboo screening, all the sorts of things people have on a balcony. And we're launching those results and having a debate with a number of glass experts in the industry in just a couple of weeks' time. So if you want to join on and see that debate, if you want to suggest questions, you can do all that on the Resi Build website, resi.build. But in the meantime, looking at glass options, monolithic or laminate, it'll be fixed the same way. You can have a fascia trim at the bottom, it's screen printed or obscure as well. That often helps avoid things like combustible bamboo screening being needed for privacy. So they're fixed the same way, both point fixed with screen print, or where you've got a fascia trim, they've just got mechanical fixings through the glass. So if you can imagine in that glass, laminate glass, you saw the second panel, it stays, it maintains its strength for a bit and then slowly starts losing its strength. If it's got a handrail at the top, it's got fixings at the bottom, that glass panel is not going to go anywhere. And that's the real big safety benefit of laminate glass. So 8.5.2 of BS 6180 has 2 parts to it. And bear in mind, this British standard is now actually 21 years old. But the 2 parts to it, one is that you've got a second form of guarding. So if you were leaning on a balustrade and it collapsed, the glass smashed, for instance, you would actually have a second form of guarding. The handle would stop you falling off. And the second is that would withstand the load by itself. Now, there was a tragic death of a young toddler in Sheffield a few years back. And as part of that, this really led the industry to really start thinking more around using laminate glass as a solution. So you've got those two forms of guarding the whole way across, because ultimately that toddler was unfortunately not tall enough to be protected by that handrail. So with that, the British standards at the time in 2011 updated this to say that basically you didn't need a structural handrail if you're using laminate. But with that, that also meant that the cost of using laminate glass was then more cost effective than using monolithic. So moving on to framed systems, the most common of which is the vertical bar. We'd recommend using rectangular bars. They're much stronger and can achieve loads with much simpler hollow aluminium extrusions. If you go for a round, you have to use a stainless steel to get the strength, and it needs to be quite strong. So it needs to be quite a thick bar, 25mm diameter, and becomes very, very expensive. Base fixing doesn't really make any difference whether you've got fascia behind or in front. It is cheaper to have the fascia behind on the rectangular bars. There's a few safety features you can simply add to this as well. There's a few on this particular scheme they've used. This one here, at the top of that handrail, you've got a slight slope on the profile. So by having a slope, it means if somebody put a glass on there or a plant pot or all those kind of items on a balcony, if it fell, it would be more likely to fall onto the balcony than fall down to the floor. One we definitely advise is the kick plate along the bottom there, which is basically just extending the fascia up very slightly by 30mm, 40mm to stop something rolling off the edge. So same with the kick or the scaffolding. There are other alternatives, perforations or solid walls, getting more common now, more glass is banned in laminate. Monolithic glass being used with a frame system becoming more and more rare because it is cost effective for a concrete one, where you need a big base channel for a structural glass, but it's actually more expensive to get this look, and doesn't generally look as aesthetically pleasing either, the structural glass. And normally it's only used in scenarios like this, which are quite are reflecting the heritage of that particular area, and so on. Any questions? We'll skip on and come back to that in a second then. So one thing we'd recommend is you use the balcony configurator we've created. This is a 3D solution which can be used on, can be found on our website. We've actually just launched the latest version of it, which is basically a 3D rendering, and you can play around with. You can get views from the inside, from the outside. You can see the angle positioning and so on, and then you get quite a detailed report, completely BIM drawings your MBS spec created. So you're choosing by aesthetics, and it's generating all the technical stuff behind it and giving you those outputs. So I'd highly recommend you have a bit of a play around with this and get the items you need from it. It's called CABS, and it's found on our website. So hopefully we've given you a bit of an increased knowledge in the area of looking at what we can learn from the past. Hopefully we've given you a bit of info on what's changing at the moment in terms of fire regulations, in terms of the British standards and so on, and giving you a bit of an approach to the future. Thanks for your time, and if you have any questions, please ask them now.
Nick, I've got a couple for you. Paul here.
Hello.
What's the lifespan of balconies typically? Have they got a limited lifespan, or are they?
We designed for a 60-year lifespan. We over-engineered them, but that's what we've got. It does obviously depend where it is and what maintenance a balcony gets. For instance, if it's on the seafront and so on, and depending on whether it's a complicated one with lots of welds and so on, it's more likely to be vulnerable. But the majority of these systems is in aluminium. It's designed for a 60-year lifespan. The anchors back into the building are over-engineered, so they're designed for a lot longer than that as well, because obviously that's the bit which just cannot fail.
Thanks. What about a testing regime? Are they something that needs to be inspected every sort of 5 or 10 years? The sort of security you fix in and things like that?
We do recommend it. We've done an extensive, with basically aged balconies quite considerably with a UCAS accredited test house, Lucidium, where we've done high-grade thermal chamber testing on different components and what happens to those over a period of time with salts thrown and all the rest of it. We've also done vibration tests, so continual vibration over time and seeing what would happen. We do have some recommendations, and I can send you a link. It is on our website as well, about a recommended testing regime. But ultimately, it's a visual inspection. Everything can be accessed from the balcony itself. It doesn't need to be. You don't need to get a sort of scissor lift or something and look at all the balconies from the outside. No, you can do that if you want. But everything can be accessed. All the bolts can be seen. If you take up some deck boards, you can actually see all the bolts within the balcony as well.
Okay, there's no statutory requirement for inspection, though. It's just a sort of good housekeeping sort of thing to do, is it?
Yeah, correct.
Lovely. Thanks, Nick.
In terms of other testing, we're obviously doing mass amount of fire testing. So our sister company, My Deck, who do the decking, they've got lots of fire testing done, and we've got an in-house test house in Reading, and we've got quite a major amount of different pieces of equipment there. So we do destructive testing on any new detail, and we normally take one balcony per project as a type, and actually test that in various different aspects as well, from natural frequency testing to strength testing and so on. So we do quite an extensive amount of testing ourselves. If that makes sense, even though it's not mandatory.
Yeah, thanks for that.
No problem. Any other questions? Okay, so if nobody else has got a question, thank you very much for your time. Very much appreciated it. And don't forget to check out the ResiBuild website for further areas of information or accessing other recordings and so on. Thanks very much, everyone.
Thank you, Nick, for a very interesting CPD. If you'd like to book a CPD with Nick, please go onto the ResiBuild website or email me on kelly.thompson@sapphire.eu.com. If you'd like to ask Nick a question about the CPD, but on the live Q&A session, please use the Q&A function below. Thank you, everyone, for the interviews and presentations. It's clear to us from many of the interviews that collaboration is a big point. And secondly, the strength of adoption, perhaps closely followed by other factors in the industry like competitiveness, labour and speed. We'd like to introduce the panel that we've got here today. So we have Daniel Leach, Tom Hall, Luke Horton, Ken Davey, Regan Cook, and our own Nick Horton there at the top as well. Firstly, we'd like to ask a couple of questions to the panel. So the first question that we have is, will the current economy drive people away from MMC or towards MMC? Perhaps Ken, you'd like to start that one?
I think there will be a drive towards MMC for a couple of reasons, if not only to limit the number of operatives on a construction site. I mean, it must be seen as being one of the main ways of actually dealing with ongoing distancing. So I think MMC has a big part to play in the next few months and years ahead.
Tom, would you have anything to add?
Yeah, I think it's a difficult one, isn't it? I think it's definitely a massive, a further opportunity to take advantage of progressing different ways of construction this crisis. I think it's as I said in my talk, I don't think it's a panacea though. You know, there's been other blockers there in terms of lack of investment, lack of confidence, lack of willingness to take risks that remains, and until some of those blockers are removed, it's difficult. It's difficult to see how it may be, how it may be progressed really.
Okay, and Daniel, do you want to add to that one?
Yeah, I mean, I think there's been a general shift towards MMC, off-site manufacturing, and modular type developments for a while now. I mean, it depends what you sort of term modern methods of construction, really. I mean, I think one of the things that definitely will happen off the back of the COVID-19 situation is that hopefully construction technology solutions will start to be used more widespread. So even just things like this event this morning that obviously, ordinarily would have been held at someone's premises somewhere in the country, and we'd have all spent considerable time in the car or on the train traveling to and from. And we've managed to hold, the same quality of event with the same content and the same people, but with everybody working remotely. So I think from my perspective, what I'd like to think is that construction technology and innovation will start to happen, because a lot of people will have been exposed to things like video conferencing, shared channels. We use systems like Slack and Microsoft Teams for sharing information now that, again, probably 6 months ago we were looking at, but now everybody in the organisation's using it day to day. So I think from my perspective, that's definitely a plus.
And Nick?
Yeah, so building what Dan says, really, and I think one of the interesting things with the whole COVID-19 social working is the fact that you've got so many different trades which are used to working right beside each other, and actually in many cases actually need to work beside each other as well. One person holding the other end of an item which is quite heavy, and it's that kind of thing which I think is probably going to be becoming more and more off-site produced. Certainly from the discussions we had on the external envelope event we ran a few weeks ago, that was quite a clear message then, was that the industry was generally felt to be going towards a route of MMC because of the fact that people are going to be struggling continually with some of these jobs which are just too difficult to actually turn into a socially distanced one while on site.
And Luke, would you like to add?
Well, yeah, thanks, Kelly. Linking on with what Tom said, really, I don't think it's necessarily going to totally accelerate MMC, because there's other challenges to bear in mind, or changes of mind needed to embrace the whole MMC journey. But certainly one of the things that may have happened through this pandemic is maybe people have seen a different set of benefits to MMC that they hadn't realised before. And certainly we've been able to keep all 4 of the factories manufacturing during this period, whilst some sites have totally ground to a halt. Products being made in a factory environment has been much more controlled. So we've certainly managed to keep the progress going despite sites slowing down. So we're now very ready for sites when they're ready to take product, but there's obviously the social distancing benefits that you can bring, and just less labour on site. You imagine all the traffic going through the turnstiles and canteens and so forth. It's just, you take away a big problem using MMC. I don't know if that helps.
That's great, thank you. And just like moving on to the next question, does collaboration up front mean you lose savings further down the line if you had to keep it generic? Would someone in particular like to answer this one first? Yeah, Luke?
I'm happy to say that probably the reverse is true, that if you ignore it up front, then you're missing out on savings, and you're potentially duplicating design work that then needs to be redone when you do make the decision to commit to an MMC route. As I tried to demonstrate earlier in my presentation, it's really the looking beyond just maybe the value of a product to see what knock-on effect it has on other trades and other people that are doing work on a project.
Good, thank you. And Daniel, also you spoke quite a bit about collaboration on your presentation. So would you like to add?
Yeah, I think the challenge is probably more about how do we as an industry change the way that jobs are procured to allow that early engagement. I mean, investing early in the digital asset is an absolute no-brainer. The savings that can be made are tenfold based on what the level of investment is that's required. But I think I alluded to it with regards to the sort of the UK procurement model. I think one of the challenges that we've got is that the architect and engineer are typically appointed by the actual end client prior to a main contractor and supply chain being appointed. And what that creates is a mechanism where the main contractor that gets their price the most wrong wins the project, because obviously the information they're working to is incomplete, understandably incomplete. And that then same information is used to go down the supply chain, and all of the supply chain businesses that get their prices the most wrong also win the project, and then we all beat each other up trying to build it and construct it. So I think that, you know, the reality of the industry is at the moment that it's become sort of more multidisciplined and more diverse. There's more products available on the market. So, you know, if an architect or an engineer is trying to look at a balcony as an example for today, if they don't know who their balcony supplier is going to be, how far can they take their, you know, the digital asset, the digital twin? And of course, similarly, organizations like Sapphire, if they're going to put their expertise into the digital asset, they're going to want to know that their product is ultimately going to be purchased. So I think the question is more about how do we change the current procurement model, because at the moment, incomplete information is being utilised to price, which is creating huge uncertainty and price uncertainty. And then I think on top of that, you've got all of the knock-on consequences of design changes, extensions to program, contractual conflict, etc., etc. So I think the $1 million question is how do we tear that up and stop the risk being sold down the supply chain, you know, and try and work more accurately at the front end of the project.
Great, thank you, Daniel. I think, Tom, you were agreeing there, so did you want to add as well?
Yeah, absolutely. I thought all great points really from both Luke and Dan. I think there's a lot more people, much more knowledgeable in terms of the detail of it. I think everywhere I go, there's so much willingness for a different way of working, really. And I think just a wider understanding of the wider benefits of construction, such a key industry, and the process of cost minimization often has wide-reaching negative impacts further down the line that often leads to higher costs in the long run, and also more understanding of the societal benefits of more environmentally friendly, better constructed buildings which last longer and ultimately benefit everyone and benefit society more. So I think it's long overdue some form of a reassessment of how we go about considering the design and the whole life of a project, really. So just that, really.
Okay. Thank you.
I think the Construction Leadership Council have been looking at this for some time, and they are trialling different forms of contract, basically an incentivised contract where the risk is shared. But the government have tried this before, because they used prime contracting for the MOD estate from around about 2003 through to 2015, where it was a shared risk board and it was an incentivised contract. But I think we've got entrenched behaviours that need to be changed somehow. And having worked for a tier 1 contractor, there's a nervousness about single sourcing. And basically, for collaboration to work properly, you pretty well need single sourcing. So it's finding the right delivery model, the right contractual model to actually achieve that. And then in taking that forward, as Daniel said, obviously the design can be incomplete. Design for manufacture and assembly drives MMC. So until such time as DFMA becomes mainstream, the actual uptake of MMC is limited. But I think the potential is there, and it's actually convincing people that the collaboration through DFMA into construction industrialization using MMC is the best way of working. And it needn't require massive investment, because MMC doesn't need to mean volumetric. It doesn't need to be major components. This is where we can learn from the car industry and look at platform design and component design, and try and turn a lot of these things into technology agnostic products which can be manufactured and supplied by numerous different companies.
Great, thank you, Ken. We have actually been joined, I believe, by Daniel in the place of Laurie. Did you want to add something?
Yeah, good. Thanks. That's interesting what's come up. One thing which I think the whole industry as a whole is probably need to step back and look at, sort of following Daniel's point, is the sort of cost reallocation, because bringing some MMC components into some sites which can particularly spread across different trades is quite difficult to actually get a one cost allocation saving, or there may be a different view needed to be able to actually cost allocate correctly.
Yeah.
Nick, did you want to add?
Yeah, I was going to say, if you can picture the UK construction model, you've got this architect and the engineer being appointed. Imagine if they were only appointed by the client for stage 1 and 2, and they kept all their options open to architects until the build started. It'd end up in absolute mayhem. And that's quite recognised as being, you need that collaboration between those two parties in particular, but it's no different really further down the supply chain. And actually, both those tend to be a jack of all trades, whereas the product suppliers together working in collaboration with the architect surely creates a synergy which you wouldn't otherwise have. And rather than a jack of all trades creating these components, a balcony component or a pod for your utility room and so on, if you're getting those specialists working together, you're going to end up with a better end result, which is going to design out a lot of that cost. So surely the collaboration is just a bit of a paradigm shift with the thinking further down the supply chain.
Thank you very much, everyone. Another question that we've had sent in is the planning pipeline in industry strong enough and relevant enough to give opportunity to clients to adopt off-site in the near future? Or do we need to wait for planning applications in, say, 5 years' time? I think that's starting with Tom on that one.
Well, I think first off, the planning environment has, as one might have expected, has taken a bit of a hit in the last few months, but has held up. There's still quite a lot of earlier stage applications still going ahead. It seems that the council has transitioned pretty well to remote working and what have you over the period. So, and we also had exceptionally high contract awards in January, February as well. It's just the uncertainty, really. I would say it's the uncertainty of how the economy is going to rebound over the next few months as we come out of lockdown. And also, obviously, Brexit as well is also going to likely to create a fair amount of uncertainty over the next 6 months as well. All of uncertainty does not, as we've seen before, doesn't lead to people wanting to invest in things. So it's likely that we remain in a period of uncertainty since obviously the Brexit vote of 2016 for the near future, to be honest, unless something major changes. So sorry, doom and gloom.
Luke?
Thanks, Kelly. I was going to say, if a project's already got planning and it's due to be starting on site shortly, it doesn't totally rule out the possibility of MMC being used. And there's a number of projects where we've come in where the building can be adapted to embrace modular balconies, for example, and we've seen it. We've done exercises with some developers to totally change a building that was through planning as a concrete structure with traditional brick to something like a precast wall system with brick slips done in the factory and so forth. So we've been part of those projects, and there's certainly a bit of coordination up front between key suppliers to make it happen, but it's not impossible to do that when it's through planning. But it does make you be a bit picky and choosy, because not all schemes, certainly if the architect's been given a fair bit of scope and you end up with massive variety of balconies, for example, on a scheme, there's just not the repetitiveness there to make MMC work. But certainly the best stage to get involved is as early as possible. So it's probably those developers that see the benefits of it in many ways may want to just run an education piece through their businesses to people getting involved in the actual initial planning designs, and those architects that maybe come up with that concept scheme, that this is the way we do balconies, or this is the way these are the modular systems we want you to build into the design from the start. So when it comes out of planning, you know, it's all good to go with MMC.
That's great. Thanks, Luke. And sorry, Ken, do you want to say add as well?
One of the things that the supply chain school is pushing is to get early involvement, and to a certain extent, the clients have got to drive the demand. Now, the client may be a developer, or it may be a council, or it may be central government or local government, something along these lines. And if the clients drive the demand for prefabrication or MMC or pre-manufacture, let's call it pre-manufacture, because when you speak about prefabrication, everybody seems to think modules, and modules are only one small part of MMC in reality. But then, so if clients can drive the demand from a very early stage, even from stage 0, before stage 1 REBA, then you're going to push towards MMC. But that means taking advantage of all the other skills that are out there, which is what Daniel explained in terms of digital design. That's a key to the whole process as well. And then it comes down a level from the client, and it's getting the consultants, the designers, to understand what's potentially what's possible within the term MMC, rather than thinking, again, I'll go back to what I said, rather than thinking it's all about modules. It doesn't have to be about modules at all. It can be right down to little assemblies that one person can pick up and take onto a site, and they're saving time and effort because they've actually perhaps assembled something on a workbench somewhere in far cleaner conditions, and far safer and cleaner conditions. And they take it down to the contractor. They say the tier 1s or the bigger regional contractors. They can drive the demand as well, provided they understand what's achievable. So there's this whole thing about understanding. Even the government have said that they are predisposed to MMC. However, I'm struggling to see how the government and the people who procure buildings from whichever government department fully understand what MMC is about.
Thank you. And now, Daniel Leach, did you want to add?
Yeah, I think Ken touched upon like one of the issues that we're finding, and I mean this with absolutely no disrespect to main contractors in the main, but I think what we've seen in construction over the last probably 10 years is more and more people in mid to high level management positions in main contractors and project management companies that don't fully understand the actual process or the construction of the building. And so ultimately what you end up with is bad decisions being made. So RFIs going unanswered, TQs going unanswered, and bad decisions being fundamentally made on the project because people don't comprehend what they're actually answering or what the issues are. I think, to answer your initial point about the procurement side and pipeline for planning and stuff, I mean, if you talk to modular manufacturers as a good example, they do need pipeline. They need projects. They need volume in order to get those economies of scale. What we're tending to find on the front line is probably more that projects that are coming through planning have actually been designed initially traditionally without MMC in mind, and there's been a decision made late in the day to look at maybe modular volumetric or off-site manufacturing solutions, and that becomes really difficult because you're almost designing the building from scratch, but you're doing it at the point where the project's been approved and program started. So I think getting early stage MMC or off-site manufacturing thinking into projects is really important, and that's where I think this probably will become a cultural shift where architects and engineers that see value in it will start to surround themselves with companies that have the demonstrable expertise. I'm sure Sapphire as a modular manufacturing business for balconies is a good example of probably sick to the teeth of losing projects to companies just purely down to price. And I think that's indicative, the cheapest price isn't always the best price. Value engineering doesn't need to be about making it cheaper. It needs to be about making it better and ending up with a building that long term is better for the client to manage and operate and maintain. And at the moment, the digital asset seems to be more focused around the actual design and construction of the project rather than the ongoing operations and maintenance of said building. So I think there's a really, really big ladder to climb and lots of progress that needs to be made. But ultimately, the only way that we're going to move forward with it is if we sort of go away from this kind of race to the bottom, cheap. It's got to be looking about what the best thing is. And sometimes offsite, as a good example, a modular might not be the right solution for a particular project for a variety of different reasons. But sometimes it is, and where it is and where the benefits outweigh the negatives, then that's the direction you should take.
Great, thank you. And Daniel Freeman, did you want to add?
Yeah, just picking up on Luke's point and Tom's, with the potential drop in applications, planning applications, etc. We have noticed, though, that there's obviously this period of 8 to 10 weeks where a lot of contracts that are in the early stages have lost time, and they need to make up time, and have actually looked over to that off-site manufacturer as an option, which wasn't initially in the plan. But pick up on Daniel Leach's point, that's not always the easiest way. But I think there are possibilities out there for, and this period we've had of lockdown, I think will definitely drive people to be thinking of this on a time scale at the other side of costs, really.
Great, thank you. Nick, did you want to add?
Yeah, I think it's quite an interesting conversation around this, and what Luke says is quite a valid point around. It depends what the building is, and depends what level of MMC embracing you're going on the route of. It's quite possible to switch many balconies. There's probably no days with Daniel Freeman as well that you can switch out a lot of traditional methods for where you build your pods. I think if you're going down the route of a Langer Rourke type scenario, you need to be in there at a very early stage. And Ken, that was one of the examples you mentioned there, and that's really where the client interface and the whole collaboration there is quite necessary. Now, that doesn't mean that it's not necessary to get that early involvement, but it doesn't also mean that you're limited to having to go down a completely traditional route or completely the way building's being done, because ultimately the planning is really in the main aesthetic led, and often, certainly in the case of balconies, for instance, inset balconies may have been designed as concrete balconies. If you get that look and feel right, it doesn't really matter how they're connected back to the building, but there's certainly lots of savings to be had from that.
Thank you. Another question I've had for Ken was, how do the 7 categories you mentioned link to BOPAS?
Well, BOPAS, the Build Off-Site Property Assurance Scheme, is actually almost like an insurance approach. Lloyd's do the assessments. I can't remember, there are 2 companies involved, but it's for the manufacturers and the suppliers as opposed to the actual different elements. The categories came about through the input from the Construction Leadership Council and obviously Mark Farmer and others. So the categories are basically there to set up a common language, and I think financiers and lenders, mortgage lenders, etc., need to understand what people are speaking about. And again, it goes back to what I've said is about education. It's trying to inform people and give them the knowledge and confidence that what they see is not something, shall we say, experimental or completely innovative that they feel that they can't take the risk on. There's a degree of commonality across the construction industry, the construction sector, whether it be from the people providing the finance right through to the people operating the building. But BOPAS, I think, if someone is looking for more information on BOPAS, the best thing to do is to go to the Build Off-Site website, which is where the scheme is obviously administered from.
That's great, thank you, Ken. So another question that we've been sent in is, off-site manufacture is a great way to reduce site install time, but how can we quantify the value of this, and will the market bear it? Luke, did you want to head this one?
PMV.
Oh, there you go.
Yep. You know what PMV is, Luke?
Sorry, Ken, I didn't quite catch that. Open up what you mean.
Pre-manufactured value.
Is that the Mark Farner term from the report to quantify how much you're embracing MMC and what the value you're actually getting is from it? Do you want to explain a bit more for the audience, Ken?
Pre-manufactured value can be looked at in two different ways. One is to assess how much of the material going into a building is actually manufactured off-site, and the other way of looking at it is to look at the labour on-site. And if you PMV is purely about the materials, but in terms of actually quantifying the success, shall we say, or otherwise of MMC, is to look at the labour reduction. So the fewer people, the fewer man hours on site, then the greater extent of MMC, and likewise the greater amount of materials and products that are actually pre-manufactured, then there's far more MMC involved. But that can be from different levels. And I think, Nick, you mentioned earlier the Langer-Hurk model. They're obviously looking at it from a certain percentage manufactured off-site, and then a labour reduction, which then leads into a duration reduction as well. You'll find, if anybody wants to follow up, the PMV is explained actually in the MMC framework document. It's actually right at the end. I think I actually had the image on the slides, but I didn't actually go into it in any detail. And then obviously then Mark Farmer has looked at this in a bit more detail as well.
Ken, one question for you on that particular part, if you don't mind me interrupting it, Luke. How much of the industry actually use that as a term? I appreciate it's been created and it's used as a measure of gauging that, but is that something which people need to be educated about how to use that, or is that something which people, in real terms, people are actually using?
I think they're beginning to use it. They're looking for means of assessing the value of MMC as opposed to the cost of MMC. Daniel spoke about cost, lowest cost, which obviously is the driver behind the construction sector delivery model. I think that the PMV principle is gaining ground, and I think if there's more impetus for MMC, and shall we say that at management level you need some empirical data to prove that a different approach to construction is best, then that's one way of actually looking at it. But I think it's not something that's going to happen overnight. The term has been around for about 2 or 3 years. Can't remember exactly when Mark Farmer published the report. Was it 2015? So there will be a gradual move to this in some companies, but perhaps not in others. So it's down to the individual companies to decide how they want to measure success, I think.
Okay, Luke, did you want to add?
So in relation to the question, which I think was around speed and how you actually make sure that follows through in savings, is that correct, Kelly?
So the original question was the off-site manufacture is a great way to reduce the site install time, but how can we quantify the value of this, and will the market bear it?
Yeah, I'd say, I mean, you've seen the example of the kind of tools that we use to sit down with clients and try to put their numbers into a spreadsheet. So it's not just some figures pulled out of the air. It's actually your numbers on your site. What are you paying for the crane? What are you paying for various other services on your site? And how can we help make your site run more efficiently so you can gain those? I would say that it's been very helpful, and some of the surveyors we work with have been grateful of that, because it's hard if you're not used to MMC and how to line things up, and that's not generally part of the training. You know, we're helping them with that part. So we're very competitive on our balconies, I would say, with other options out there, and this is like the cream on the cake if you can take advantage of some of those savings. So whilst people may not be prepared to plug it into their initial lineup up front, I just take some satisfaction from it that we're helping to work with the site team to at least make them aware that if they sequence their building in such a way, or if they put focus on finishing certain trades at a certain point in the project, they can gain some savings. So there may be other things that crop up on a site which hold up certain areas, but at least if they're aware of it, you know, the speed of which the balconies can be installed, maybe rather than spreading it out in their program into 3 different batches of install, they may look to get them all in close succession of each other and actually take advantage of off-hiring the crane earlier, making those savings, which then ultimately allows them to get on with the landscaping and getting off-site earlier. I don't know if that helps.
That's great. Yes, thank you. If anyone did want to see the spreadsheet that Luke was talking about, and you've not had time to watch Luke's presentation yet, you can go back and watch it, and you can see all of that Luke was talking about there. So it's very interesting. Sorry, Ken, was you wanting to add?
Well, it's an interesting point that you're looking at a schedule with a list of costs, and when I think about MMC, I'd quite like to relate an anecdotal piece about Heathrow Airport. The delivery team looked at MMC prefabrication. My previous employer and NG Bailey were involved, and the QS looked purely at the cost and basically said the cost of this is too high. The client came along and said, actually, if we get these air bridges 2 months early, we're going to earn an extra whatever £1 million in revenue. Therefore, when you look at the value and the benefits that can be delivered by MMC, it goes beyond just a pure schedule of cost on a site. And I think that's where the lessons need to be learned. You need to look at the bigger picture. You cannot just rely on the simple costs for supply and delivery. It's a far more holistic approach to the whole thing.
Thank you. Did anyone else want to add to this one before we move on to the next question? Okay.
I think, Kelly, sorry, just one of the other things we have seen with MMC recently is a number of developers becoming aware as to how they can use MMC as part of their bid if they're up against other developers for a piece of land, is that it can really set them out differently to others bidding on a project if their approach is MMC, because you can imagine the nearby residents and people living by the site. And part of being a considerate contractor, if you can bring in less deliveries, if you can bring in less people, you know, the impact on the local neighbourhood is a lot better. They're in and out quicker as well. If the whole site is MMC, the build times can be reduced. So there's some other benefits and value there other than just purely, you know, the pound notes of the actual orders they're placing.
Great, thank you. I think we've got time for one more question. It looks like Sapphire Glide System is a two-part MMC item. Do they fit into different categories of MMC, the anchor and the cassette? Maybe Nick could answer this one.
My understanding of it is that those two are parts of the same thing. Our balcony system is really a category 5, if you like. Yeah. What we used to do when we were manufacturing balconies, more bolt-on, where you're still doing all the soffits and so on site. There's a lot more labour involved in that. There's a lot more materials coming in separately. You're putting your deck boards down and the rest of it. Instead of being 95% manufactured off-site like it is right now, you're taking that to probably more like, say, 50, 60% manufactured off-site, and that probably becomes more of a category 6 than a category 5. But in terms of the anchor connection and the cassette of the balcony, ultimately both those are part of the same solution. But I'd be interested in your thoughts on that, Ken. I know you know those categories quite well.
Yes, I think the category 5 seems to be a catch-all for all the sort of different components that are not primary structure. Categories 1, 2, and 3 are deemed to be or categorized as primary structure. But even then, it's difficult because your balconies definitely would not be primary structure, but when it comes to, say, a service riser, a major service riser, there's no reason why elements of that can't be the primary structure of the building. But I think the categories are there for guidance as opposed to being sort of cast or should we say cast in stone or you know, like the 10 Commandments. They're there to help people, and if your definition of category 5 or, you know, category 1 differs from what's in the framework, perhaps we should be feeding back and saying to the people who publish the framework, as I've made the point, I think it's short-sighted in only doing residential. It needs to have a much wider application.
Thank you. Did anyone else want to add to that one before we move on?
I would say, just to add to what Ken's just said there about, I mean, most of the modular and off-site projects that we get involved in are resi. They're either medium and high-rise resi or residential housing solutions. But the work that we've done on the two roof structures at Hong Kong Terminal 2 have both benefited from modular assembly and offsite assembly. So we've been able to look at things that typically would have been manufactured offsite but assembled on site, and we've looked at trying to design things where certain parts of the project can be assembled away from site to speed up and reduce time on site. And I think Ken's dead right. There's a lot that can be learned. I think we can take MMC and modular not just from the residential sectors, but also into a range of different projects, whether it be airports, stadiums, commercial buildings, you name it. Really, we need to get that kind of industrialized, standardized approach into our thinking and stop, reinventing the wheel every time we pick up a new project.
The Sagrada Familia post-tension structure is a prime example of that.
Great.
Just jumping back to what you were talking about then, Ken, my understanding of the BOPAS is that rather than people, warranty providers, taking the approach that a method is a bit of an unknown and therefore it needs a premium on the insurance side of things, the categorisation benefits people. So if there is obviously that pre-manufactured value we talk about, but there's also a benefit in potentially a saving on some of the insurance premiums on their warranties.
Yes, but you've also then got the BRE, Building Performance Standard, for volumetric residential, and NHBC are actually beginning to recognise that modular requires to be warranted as well. So I think there's a general recognition across the residential sector that there will be a growing delivery of housing via modular and MMC, and it needs to be covered by way of compliance and by guarantees of some form.
Great, thank you. We're now coming to the end of the event, so I'm just wondering if the panel would all mind just giving one takeaway point on MMC. So Tom, would you like to start?
I think all of these things are removing blockers that have historically been there from adopting MMC in more in greater volumes. I think there's been some really good points today in terms of economies of scale and what have you. I think potential shortages of labour with Brexit is likely to be another potential driver towards MMC to save some labour. But yeah, I think this crisis isn't going to be a panacea for the industry, but it is another opportunity to look again. And it does feel like they're certainly talking to people. It's people are having their views changed, and that is a fantastic thing. And there is an opportunity there. So yeah, finish on a positive note.
Great, thank you, Tom. And Daniel Freeman?
Yeah, I think picking up on Daniel Leach's point earlier really as to the putting the time into the project early on, which is a game changer really. It's where you put the time and effort up front is where you actually save off the back of it. But as Daniel said, it is going to it is a challenge to get the industry to change that way of thinking, but it is getting there.
Great, thank you. And Regan, did you want to give your one takeaway?
I was going to agree with what Tom and Daniel have said is good. Main thing I was thinking about was what Ken was saying as well around the education piece. We saw it on Trinity, the project we did there, that really the collaboration up front actually enabled them to optimize the product to work better for logistics, etc. When if they hadn't thought of that, it's a bigger saving picture again, but it's that education that needs to come from the architect to actually, I guess, generate those savings further down the line.
Thank you, Regan. And Ken, did you want to give your takeaway point?
I think MMC has massive potential to not to solve every problem. As Tom said, it's not panacea, but it can certainly help. But to introduce more MMC, we need DFMA. And I think that goes back to the education point that Regan just picked up on. So DFMA is the enabler, and we need to see more education on implementation of DFMA in the design community, and we've spoken about collaboration, and that's one of the keys as well. And I think that's a behavioural issue as opposed to anything else. So we can change behaviours. People are more open-minded. We might see far greater uptake of MMC.
That's great. Thank you, Ken. And Luke. Right, Luke, you able to give us your takeaway point there?
Sorry, slight technical issue there.
That's all right.
Yeah, I'm going to quote Stephen M.R. Covey because I think he's got a really good speech. He talks about the speed of trust, and I think that's a really powerful thing. Trust, where trust is high, then cost goes down and speed goes up. And I think if we can work as an industry on building high trust relationships, in my view, that's one of the fundamental things which is holding back the progress of MMC, because there's a lack of trust and a belief that the only way to get value is that we have to tender everything. We have to keep our options open to the last minute. And certain relationships with supply chain are kept at arm's length. So if there can be a change of thinking there and a willingness to maybe experiment with trust and actually get closer to fewer people that support the way you want to take your business and recognise these savings, I think there'll be some benefits reaped for the whole industry. So my takeaway is to work on some trusting relationships between supply chain and yourselves as developers and architects and leaders in the industry.
Thank you very much, Luke. And Daniel Leach, have you got your takeaway point?
Yeah, it's probably just to sort of almost rebound on what Ken was saying about DFMA. I mean, I still fundamentally think that we're not going to get DFMA into the project until we look at the way that jobs are procured. I still think that the way that jobs are procured is the central biggest blocker to MMC and to getting that digital asset done. You know, at the moment, and the architect and engineer and main contractor doesn't have the manufacturing expertise for the variety of different products that exist in the market. So how do we get that expertise into the project earlier and go away from this whole selling risk down the supply chain? You know, ultimately, I agree in principle with what Luke's saying, that, you know, ultimately the balcony costs what the balcony costs. Can it be cheaper? Yes, absolutely, but that might be sacrificing a bit of quality or et cetera, et cetera. So ultimately, I think we've got to find a more transparent mechanism for pricing jobs, so that we can get that early engagement and as Ken said, get the DFMA side in. I think if you said to 95% of manufacturing businesses across the country, would you rather have to take the design and detailing liability for your product and price to incomplete information, or would you prefer to price to complete information with no design risk? They take the latter one every time. You know, manufacturing companies want to manufacture, and unfortunately that's resulted in the drawing process and design process being a necessary evil for lots of those companies. And I think until we place greater emphasis on the digital asset at the front end, then things aren't going to change.
Thank you, Daniel. And Nick.
I'll go back to a comment which came up at a design meeting I was at with an architect, an engineer, a developer, and another product manufacturer. And the developer asked the product manufacturer whether, if we did it off-site, would it be more cost-effective or if we used MMC? And just a blanket no. And I think the collaboration is key, and it needs to be seen as an opportunity. And there are certainly people which are spending a lot more time doing it, and some developers are very good at it now. But I think one thing which also really muddies the water is this whole definition thing. What is off-site manufacture? What is DFMA in reality? And it's quite easy for any company in many different industries to say, oh, we manufacture our products off-site, but a brick is off-site manufactured as well. As Ken pointed out in his interview, the fact is that nobody sees bricklaying as half being done off-site. The fact is that I think there's a lot of work which needs to be done around that, so people actually measure the value of different things rather than look at it as a tick box which you tick. Am I going off site or am I not? It's not an option thing. It's more of a how much do I want to embrace this and what are the benefits of embracing different levels of doing that.
That's great, thank you. So I'd like to thank everybody for joining us today. So all of our panelists, thanks again for your time, for your presentations and also your interviews. And again, thanks for your time today, joining us and answering those questions. So everyone that's joined us today, thanks for viewing. I hope that you've learned something new. If you do have any other questions, do send them in to us and we can always approach the panel for you and get those answered for you. We do have a couple of questions for you now as the viewers, just try to help us continue to improve our events. But yes, thank you very much for joining us. If you haven't missed anything, you can re-watch the videos on the link given to you and do share. So if you know anyone else that would like to watch, just send them to our site so we can send them out the link. So thank you very much, everyone.
Thanks, Kelly. Good to be with you all.
Very good, thank you.
Thanks very much.
Bye.
Cheers.